Good morning, everybody. How are we doing this morning?
Good.
Good. We got
Good. How you doing, Matt?
good. How are you?
Pretty good.
Good. Patrick, your mic's off if you're trying to talk to us.
Love it when that happens. Is that Ricky's voice that I'm hearing?
That is correct.
Good deal. Thank you, sir. Good.
I can't pull up
For the
a video
people.
on here.
What we're going to do is we're going to go ahead and jump into this thing. We're probably going to have some other people popping in, whether they're having issues getting on this morning or whatever. That's on them. What I'll do is just ask you that talk as much as you want. When we have something come up or you have a question, just pop your mic on and kind of interrupt me if you need to. We will go ahead and record this. The session itself will probably be hosted on our website. This is part of Safety Fest, so you might be able to get back to it. If you know somebody who wants to be part of this or wants to see this session, feel free. We're probably going to be doing some more of these with JSI and NAHB throughout the rest of the year, but the grant is coming to an end soon, and that means this session will come to an end. So I appreciate everybody taking a few moments and being part of this. This is the longest of the Safety Fest sessions, so this will be a 4-hour session a day. We do have Brad Hammock tomorrow. He's an extremely good OSHA lawyer, so he'll be on tomorrow. We have Judy Swartley, who's we call the drug test lady. She's with Red Planet. She's going to be talking about saliva tests, not only for drug testing, but also the new COVID testing that will be instant tests that will be able to be done on job sites. So I think that's pretty interesting coming up. Thursday, we have a doubleheader. We have Preferred Insurance talking a lot about how to help out with your insurance programs. And we also have George Stallings talking about the shortages of PPE and what to do about it. Great guy there. And then I'm going to silence your mic there, Pat, because I'm getting some background noise from you. There you go. If you need to pop on, just go ahead and click that microphone again. And then Friday, we'll finish out strong with, so far it's Maryland OSHA and Federal OSHA that's going to do a little check-in, tell us what's going on and what they're looking for. So just wanted to kind of get that going. We'll get going with this presentation. Again, if you have any questions, you can put up a chat. I see Pat found that with the no worries. I appreciate that. You can also just turn your mic on and chat from there, and then we'll go from there. Patrick will be sending out links as we go through, and here in a few minutes, we're going to send out our first link, which is our pre-test. OSHA requires a pre-test and post-test during the session, so we're just going to ask you to click on the link when it pops up on your screen and fill that out, and then we can check that out. It comes up in the text box that you're checking in right there, Patrick, right?
Mm-hmm.
Okay, so it'll pop up right there. So just click on that, take it, and it'll pop back, and then we'll go right back into the session. So any questions? Not everybody at once.
No, looks like we're pretty good.
Okay. We're expecting probably, I don't know, half dozen more, but just as they pop in, you can just put the text to them, Patrick, and let them know what to do. We'll keep going.
Yes, sir.
Cool. All right, let's get back with this session. So again, this is brought to you by JSI and NAHB under the OSHA Hardwood Grant. So it's completely free for you guys to attend today, and I appreciate you taking advantage of that. Here's the fun disclaimer. Anytime you have the OSHA class, they want to go through the disclaimer. Make sure you understand that this is a awareness class as far as they're concerned, and that we're talking federal. In Virginia and Maryland, obviously, we have state programs. We'll talk a little bit to that, but the program's based on the federal standard. All right. It's going to break up into these 6 sections. Introduction. And again, after the introduction, we'll do our pretest. Then we'll go into ladders, scaffolds, conventional fall protection, additional fall protection, and rescue by the end of it. Toward the end, we will also have a survey and a post-test. Since you can't be here live to sign, we need all 3 of those done and returned to make sure that you've qualified to be in the entire class. So just an FYI there. So course objectives, we want you to figure out what are some common fall hazards, which I think you guys know, but we'll talk a little bit about them. Identify when fall protection is required, determine which system to use, understand key requirements, and understand safety requirements and practices for ladders and scaffold. So as we get into the overview, why is fall protection important? Why is fall protection important to you, Ricky?
So you don't get hurt.
There you go. That's pretty simple, right?
As basic as it gets.
There you go. I like it. All right. That's why it's important to me too. I've fallen before. It does suck when you fall, right? It's all good right until you land. And that's where it starts to hurt. So we definitely don't want to do that. We also don't want to get anybody killed. We also want to identify common fall hazards. We also want to figure out what is residential construction. Everybody wants to say this project's residential or that project's residential. What does it actually mean? Understand the importance of fall protection training and understand competent and qualified person requirements. What's going on here? That looks fun. How do you like their fall protection system? Let's start with that.
No harness.
Yeah, not a harness to be seen, right?
Not one.
How you like that scaffold? I guess you call that a scaffold. I don't know what you call that. That's some stuff right there. I mean, take a look at that. You got this nice pump jack on these nice wood boards with whatever these braces are here. And then this one definitely hasn't had its V8. It just kind of curves over here.
Shaky.
Oh yeah, that's horrible. Look at the scaffold back here. Look at those walk boards. Nothing is fully planked back there. Everything's hanging over. It's just terrible. Not a hard hat to be seen on these guys. And no fall protection. I guess they did leave a trash pile, so if they're going to fall, I guess they aim for this section right here. I don't know. But that's a no-go right there. If you're OSHA and you're driving by, do you see something that's immediately dangerous to their life and health?
Yes.
Yeah,
Absolutely.
yeah, so you just invited them onto your project by doing this. Okay, that's how OSHA comes into your site. They see something, part of the Fatal Four, falls from, struck by, caught between electrocutions. National Emphasis Program also kicks in some silica and stuff like that. Those are ways that OSHA can come out. They don't just drive around and happen to be trying to make sure you're having a bad day that day. They're looking for stuff like this that, I mean, my goodness, their common sense button's a little stuck there. So they need to unstick it and give them a nice little citation to keep it unstuck, I guess. So we don't want to see that out there. So hopefully by the end of this course, you'll figure out how to identify that and correct and eliminate that on your job. Also figure out what regulatory stuff. If I say 1926, 503, I'm going to be talking about fall protection training requirements. I'm going to give you some sections that you can take back and go to OSHA.gov if you don't have an OSHA book and go look at this stuff for yourself. I'm never satisfied with just somebody telling me. I want to see it in print. I want to see the rules. So I try to put that into the class as much as possible too. All right. Hopefully you'll take this back and provide training to some employees, develop fall protection best practices for your company, your job site, and understand what you need to do with conventional fall protection systems. So let's look at the facts. Between 2003 and 2010, 1,917 workers died in residential construction industry. Nearly half were falls from the roof. Does that surprise anybody? Residential roofing was 80%, and then ladders accounted for 23%. So, I mean, that's a lot of workers in a 7-year span. That's for sure. We don't ever want to see that. How far do you have to fall before you die? That's always a good question. Pat, Ricky, how far do you have to fall before you die?
Any feet.
Any feet. I like that. Yes, you're right. Any feet. Ever heard of somebody tripping or slipping in the shower, cracking their head, and they're gone? If you fall 6 feet, you hit with 10 times your body weight. So if you're, say, 200 pounds with tools, you're hitting with 2,000 pounds, right? So that's just falling off of a 6-foot ladder or just falling, off of a level 6 foot above. 10 times your body weight. That's going to hurt. I'm sorry. It's just the way it is. So we've got to start thinking about fall protection from the ground up. Here we can see in 2015 where the falls occurred. All right. Less than 6 feet. 10% were less than 6 feet. That's pretty crazy. These are fatal falls to a lower level. If you're worried about OSHA, I think they just got the 18 up, so that'll be coming up soon. But look at the top 10. Fall protection has been number one, the last 15, 20 years that I've been part of safety. Fall protection's always been in the top 10, and usually it's at number one. Scaffolding, general requirements, ladders. Again, we're going to talk about fall protection training requirements. Usually you see that system that we just showed you with the roof with the two guys up there. Do you think they've ever been trained how to use fall protection? So they already get their citation for being up there and getting ready to go splat. And now they're also going to get cited because they never had training on it. They may also get cited for not having a written program. They almost, there's multiple citations that they can get out of that one section. Personal protective equipment. Eye and face is number 5. Number 6, what is that?
Hard hat.
Yeah, hard hat. Everybody thinks hard hats are for everybody but them, right? But nope, hard hats will get you cited. And if you look at the new citations, I mean, it's $13,494 right now. That's what the serious citation is. Is that worth it to not wear a hard hat? I don't think so.
I'm good.
Yeah. Then HAZCOM, that's your chemicals, right? Learning what's wrong with WD-40 and why you can't eat brake cleaner and all that fun stuff. That's where HAZCOM comes in the top 10. Scaffolds and aerial lifts is 8. 9 is general safety and health provisions. That's usually not having a safety program, not doing inspections. Those are right in what we call subpart C of 1926. And then fall protection system criteria. Did they have the right type of harness, or did they have the right whatever to use for fall protection? That's where it comes back in on 10. So if you're worried about the OSHA citations, fall protection is pretty important for you as well. All right, 2017, 32,000 citations were issued in the 10 most frequent that I just shared with you. 2.6 million was the largest citation, and there was almost 7,000 for number 1, which was fall protection. So a little crazy. We're still going through this stuff with fall protection. Fines. So fines have continued to go up. Back in 1990, they bumped it up to 7,000. That's where it was almost my entire career. And then in 2016, they increased, and they've been increasing every other year since. So now a citation, serious or other than serious, can be $13,494. If you fail to abate, they can charge you that per day because you didn't take care of it. And then if they find it again in the next 3 to 5 years, bam, $134,937 for willful or repeat. So it's getting steeper. So just an FYI. What's going on here?
No harness again. No hard hats. On the roof of it. Edge of a roof.
Yep, no harness, no hard hats. You're exactly right.
On
there.
barrel tile.
Yeah, they could fall straight down that material chute too, right?
Absolutely. Get stuck in there.
Yeah, so I mean, guardrails, harnesses, something, but this isn't good the way it is. So glad that we can recognize that and make sure that doesn't happen on your job site. Check this guy out. Do you think he's trying to tie off to rebar?
No, not at all.
I think the wind tied him off to rebar, right? He's walking, the harness kind of blows in the wind, kips over that rebar. If it yanks him backwards, what happens?
No.
He can become a shish kebab really quick. All he needs is caps on the rebar, right?
Right.
The other thing is not tying back to himself. Everybody does that. They take the lanyard, they go from the back D-ring, they bring it up, and they clip it on their chest strap. Well, that just makes a grab point. So if you're walking around rebar, if you've got a forklift going by and the wind does the same thing and puts that on a fork, how quick's the operator going to be able to stop? Right about after he goes over you. So that always needs to be on the breakaway ring, which I'll show you that on a harness when I pull the harness out in a little bit and we do a demo. Or it just needs to be tucked in there to where it can just be pulled out. Never tie it back to yourself. That's a big no-no. And of course, cap your rebar. All right, OSHA. OSHA allows you, we talked about you can slip same level, crack your head, and be dead. So OSHA allows you up to a 6-foot running head start, right? Their minimum set of standards. What do I mean by that? When OSHA says at 6 foot or above, you have to be either tied off or have guardrails or work off of a ladder or scaffold or other means to be safe, they're giving you the absolute furthest that they're going to allow you. Can you tie off at 4 feet? Can you tie off at 2 feet? Certainly you can, but you got to have the right gear to do it. So we'll talk about that as well. Here we go. We got the guy with, I guess that's his super cushion under his knees that's going to hold him up there so he doesn't fall, right? And I guess the guy with his hands on his hips, the spotter, I don't even know what they're going for there. Can we change them up? Can we make them safe? Anybody have an idea?
Yeah, same story. Same harnesses, just kneeling on a slide. It's going to go down that roof. You can have
Yeah.
hard hats on. You can do a bunch of stuff.
Yeah. So tie off, get your hard hats on. Exactly. So we have availability. We just need to use it. Scaffolding. Anybody ever see scaffold that looks like this on their job site?
No, sir.
Only when you tell them you're going to shoot an OSHA video does it show up like this. Look at that thing. It has a nice old built-in ladder. This is the built-in ladder system, by the way. A lot of people go, oh, it's got a ladder. See these rungs? You can climb them. You can climb them, but that's not legal. You got to have a ladder actually on your scaffold. Then they actually put in the stairway too. So you have 2 means of access to get up there. That's pretty doggone good. I guess you should tell every time you rent scaffold that you're doing an OSHA video or something, you'll get something that looks like this.
Yeah, I need stairs.
Yeah. Check out what's on the front of this outrigger. Anybody see this? What's that?
That's the door, right? Is that a swinging?
It's an end rail. They do make them. It's not just another bracket hanging up there, which is what your masons love to do, right? They do make end rails. You're supposed to use those. That's why your outrigger has that little hole down here. Just kind of blow it up a little bit. That's why you have that hole right there to put that rail in and then clamp it back to the side of the scaffold there. Mud sills, right? We got to have that underneath the bears, so that's good. We even have uplift pins in this thing. That's really good. So, yeah. What about ladders? How high can we go up a ladder without tying off? Pretty much all the way up. In subpart X, it doesn't tell us we need to tie off. And if we tie off, what are we going to tie off to, right? The ladder's not going to hold us. So if we can tie off to the building, is it a good idea? Sure, as long as we can do so safely and we don't pull what we're working on top of us, and it'll hold us in a fall. But in a ladder, as long as we're not on those top 2 rungs there, which he's not, there's your top 2 rungs, right? That's the top of the triangle. We're golden. He can work there. And if anybody's ever done this before, what's he doing? He's setting floor joist system from the ladder rather than on the top plate. Top plate's this part right here. How many of us have ever walked top plate before and sat this stuff? It sucks. We're working at our feet. We're bent over with our backs hurting all day. If you're working here, he's working between his hips and his shoulders, so he's working in his power zone. So he can do this a lot more than standing up there, bent over, trying to toenail these floor joists in. So this is a much better system. There's no trigger height for ladders for fall protection. We have several states that have their own OSHA, right? So California, Kentucky, we have 2 right here. Maryland and Virginia have their own state OSHAs. So we'll talk about if they vary at all. They don't vary very much when it comes to the residential fall protection deal, but we'll talk a little bit about that as well. Where do you start with all this? You need to understand what OSHA is requiring from you, right? You need to read the rule book. Just like if you go play a game at somebody's house, you have to establish the rules right off the bat. You can't make them up as you go along. Evaluate the fall hazards that you have. Implement fall protection systems if need be. We need to train workers to identify the hazards first, and then we need to train them what we're going to put on them. If we put a harness on them, we got to train them to use it correctly. We need to train them how to store it correctly, how to inspect it. What do we expect from them out of that harness? We need to appoint a competent person. Who on here is competent? Raise your hand. Well, I can't see a couple of you, so Ricky's competent. Good. Who makes you competent? Your employer, right? Background, training, experience, ability to recognize a hazard, authority to take immediate corrective action. That makes you a competent person. And then if you need to, you might need to develop a written fall protection plan. And that's found 1926 502K. So if you go to 1926 502K, and we'll talk about it several times, it's going to talk about when you need to have a written fall protection plan. If we can tie somebody off, we don't necessarily need to do a written fall protection plan. But how do we get them there? Does that person need to install an anchor point first? Can they do it safely? Or are they the first one up on the roof to nail down the anchor point? So we'll talk about that a little bit later on. Fatal accidents. Here was a worker working on a one-story pitched roof, residential structure, putting the little vents around the PVC pipe, vent pipe. Near the peak of the roof, fell through a fireplace chimney opening. So he had a little flat spot up there. Oh, that flat spot was covered, by the way, with 1.5 inch styrofoam. He jumped down to it. He went all the way down to the pit where the fireplace was going to be, killed him. What could we have done here to make sure this person didn't have to die?
Can't this again be taken care of with harnesses?
Yeah, he could have been in a harness. Yeah, that's true. Yeah. What else? Maybe something more than 1.5 inch styrofoam covering the hole, right?
True. Yes.
Yeah, I mean, if that was plywood and he bounced down to it, may not have had an issue at all. What do we need to have for a hole cover? Something that's going to hold 2 times the intended load. Needs to have a big old sign on it that says hole or cover. Needs to be secured in place. If we would have done that, this person would probably still be with us. But we lost this one. Loss number 2, drywall finisher, sanding the second floor hallway, right? So he's standing on the open-sided floor above the concrete first floor, and he's sanding, and then he slips off the edge behind him, falls back to the concrete below. He's dead. Guardrails were there, but they were removed by the drywall people so they could get the drywall and the doors and windows and stuff up to the second level. What could this person have been done differently so that they'd still be alive today?
If everything was delivered on their end, they could have reinstalled the rails or some sort of rails.
Exactly. How long does it take to install the rails, right?
Right.
Long enough for this person to be alive. That's how long.
Absolutely.
So, I mean, you're talking about setting up your own failure point at that time. That's the bad part there. That person could still be alive if they took the 5 or 10 minutes to put the rails back up.
Yes.
Accident number 3, carpenter working on doing some gutter work on a house, climbing up the extension ladder to set up. He was on stone pavers, and while climbing, it kicked out, and he fell. The ladder fell to the left. He fell to the left. Again, you get stone pavers, you get a little bit of moisture, you get a little bit of slime on them from moss or whatever. Is that really a good, secure foundation? Probably not. And he found that out. If he would have tied that ladder back, or he would have staked that ladder, he would have been probably better off. So there's just some ways that people have passed away in construction on a regular basis. So, don't be one of those people. Let those things be little flags in your head. When you get there and you got to go up on a roof, you go, you know what? I need to take a minute. I need to put a harness on it and go up there and tie off properly. Or I need to make sure I can work off a ladder instead. That's really, by this training, what we're trying to do. Install those little flags that'll pop up. Hopefully that'll help your common sense button open up and you'll be okay. What is residential? Again, it's a wood frame construction, traditional methods, and it's in use will be a home or a dwelling. That's really what it is. So this, yeah, sure, that's a home, right? How about this? What do you guys think about that? While it's not wood, it's also using 2x4 metal studs. This could be, depending on what the end use is, this could be considered residential. This is not going to be considered residential construction. Everything's poured in place concrete and steel. You're not getting away with some of the little leniencies that residential construction has here and there on a structure like this. And this is also residential. So evaluate fall protection systems. It's the competent person's role to evaluate the fall protection system to be used and choose the appropriate system for each hazard. When we talk about OSHA, we really got to start looking at the hierarchy of controls, right? So first thing we got to look at, if we need to get on a roof, why do we need to get on the roof? Can we do something else? We've got people doing estimates and stuff like that using drones now so they don't have to get on the roof. So there's other ways. Can I see it and work off of a ladder? Maybe I don't need fall protection. I don't need to get on the roof. So first thing we got to do is figure out, can we get rid of the hazard? If not, can we put an engineering practice in place? What do I mean by that? Can we put a guardrail up? Can we put the floor hole cover on? Can we do something to protect ourselves so we can't fall? That's the engineering. Then we look at administrative controls. Do we have the training, right? Do we have do we have exposure? Do we have training? Do we have the proper gear? And then finally we go to PPE. So that's when we suit up with the harnesses and stuff. So competent person also needs to understand manufacturer's recommendations and limitations. So everything you buy, doesn't matter if it's a safety boot, a harness, an anchor point, whatever, it has testing data. It has instructions for how to use it. You have to follow those instructions. You do so and something goes wrong, you kind of share that responsibility back to the manufacturer for their testing regulations. If you did close enough or used whatever was in your tool belt to secure something rather than what the manufacturer asked and something goes wrong, that goes back on you. So it's very important when we choose the system that we use it correctly. So what is a competent person? Again, training, background, experience, has the ability to recognize the hazard and can choose the best system to take care of that hazard. So they also have the understanding from the employer that they have the right to take that immediate corrective action. They don't have to call the office first to see if they need to buy 6 more 2x4s to slap some guardrails and windows. They just do it. That's what's going to make them the competent person. If you haven't had that conversation with your employer, have that conversation, because you're supposed to have a competent person for fall protection on every job. We'll talk a lot more about competent person job coming up here. They're supposed to identify and fix the fall hazards, authority to stop work, authority to take immediate corrective action, which we talked about. Fall protection training, OSHA requires just about everything you do to have training, but it specifically lays out in 1926-503 how we train the employees. What are they supposed to be looking for? And that's one of the few parts in OSHA where it actually says they expect the employer to certify in writing that the employees have been trained on fall protection. So, whether you're using personal fall arrest systems, safety monitor, controlled access zones, any of that stuff, you have to be trained on it. Everybody who's using it has to be trained on it. So keep that in mind. All right. I think now's a good time, Patrick. We're going to go ahead and throw up that first link so everybody can do the pre-test. We've given everybody time to kind of get on now. And when this link pops up on your screen, just click on it. It'll pop up on your phone with a Survey Monkey. And Patrick can take it for a few minutes. You guys go ahead. When Patrick tells me we have all the pre-tests done, I'll continue to go on with the presentation. So it's on to you, Patrick.
All right. I am posting the link again. This is for the pre-test. And the link is in the chat area. You can just click on it, either if you're on a laptop or even a mobile phone, and you'll be able to do it. And I will keep an eye on who's doing what.
If you don't get it for any reason, let Patrick know. He can also email it to you if need be, or whatever you need in order to get this.
By the way, can I be heard on this?
I hear somebody.
Yeah, I'm having difficulties with my laptop this morning and on my phone. I can't see me. I'm on the phone listening, so
That's fine.
I'll inquire for that test a little later. I'll let Sarah know I'm having difficulties. I'm actually anyway, working remotely here, so.
I got you. Patrick's our moderator for this, so any tech questions you want, just shoot them to Patrick, and he can try to help you out and get you up and rolling.
Yeah, it's on my end. I let them know. I let my company know this is my phone, but right now on my laptop, it won't engage.
I got you.
Why don't you?
What browser are you using? In order to get WebEx to work, you either need to be on Google Chrome or Firefox. So that might be a problem with the laptop too. So you might want to try that. We've had that with some past classes.
Yeah, I'm on Google Chrome.
Okay.
Just can't get in my email to join the meeting.
Gotcha.
I would do stuff on my phone, but I can't seem to get the app downloaded to be able to be seen through the screen. I can
Okay.
do
Why
it.
don't,
I'm taking.
why don't you real quickly go ahead and just tell me what your mobile number is, and I'll be able to text you the link to the
Test.
to the test.
703
703
798
798
8394.
8394. All right, give me like 2 minutes and I will be able to text that to you.
Did that
Okay,
link
thanks so
pop up
much.
for everybody? Did you get the link going, Patrick?
Yeah, yes, and I will. Looks like there's one person who needs the email. So
I
I will.
didn't receive a link yet.
Pat, was that Pat?
Yeah, sorry.
All right, let me see. Let me try it one more time, and then if you still don't see it, let me know, and I'll be able to send it out via email. Give me 1 second. All right, let me know if you see that link posted in the chat area.
I see a link in the chat.
Okay,
Yeah.
there you go. Great. I hate to say it, I might have sent it to only one person. However,
So when I receive this, I can click on it and start, or
yes, you can.
okay, thank you.
You are all set to go. And let me. So I need this is the phone. And the gentleman who gave me his 703 number, can you just real quickly tell me what your first name is so that I don't keep saying, hey, you?
Oh, yeah, it's Jim.
Jim. All right. Thanks, Jim. I am working on that right now. Give me 1 more minute.
Thanks so much.
No problem. Okay. Let's see. All right, I just want to double check in with everybody. Did you guys see the link in the chat? And if so, are you still working on the? Are you still working on it?
I'm still in the middle of testing.
Okay, just checking.
Thank you.
I currently show 1 returned right now, Patrick. Just an FYI.
Yeah. All right, Jim, I finally managed to do this for you. Go ahead, and you should have received a text message from me. If you just click on that link, sorry, that will give you the pretest, and you can just do it straight from your mobile phone.
If you can't be heard right now, I did click off a few of you and mute you because you were just making noise. So I just did that, but you can click yourselves back in. We forget to mute ourselves a lot of times with these classes. We'll give another minute or two to finish up, and then I'll keep moving forward.
Thanks, Ricky. I received yours completed. Thank you.
You're welcome.
Hey, Jim, I just wanted to check in on you. Did you get my text message? He might have had to step away. Oh, there he is.
Anyway, but my boss is calling in, so it got interrupted. I'd say go ahead and move on. I'll still take the test, but I can listen in on the class as well.
Do you need me to send you the link again? Would that be helpful?
The problem is he's calling in, so it's taking the screen, and I'm not savvy enough to try to
I see what you're saying. I see what you're saying.
You might be able to email him.
Hey, Jim, do you have your? Do you want to give me your email real quick, and I can email it to you?
Yeah, you can. J Mockabee, MOCKABEE, at the letter K, the number 3, the letter C, the letter G.com.
So I have jmaccabee at k3cg.com.
That's correct.
All right, I'll go ahead and email that to you, and you let me know. Just respond to the email and let me know you got it.
Okay.
And if you need another minute or two to finish, just go ahead and finish while I'm talking, but I'm going to keep rolling through this. We got a lot of information to go through. So thank you for those that got it through already, and those that are working through it, we'll get you through it, I promise you. And if you need to, you can always just text Patrick in the chat box there to Patrick or whatever, and he can help you out as well. So back to fall protection training. Employers need to train employees not only on the proper use of the fall protection equipment, but systems and limitations of those systems. Also how to inspect, which we will do today as well. If you have harnesses that you want to fit at our break, we're going to run into a break here around 9 o'clock, and we'll take 20 minutes, half hour to return your phone calls, do whatever you have to do, and then we'll leave the window up and we'll just start back. But if you have a harness and you want to put it on and get some feedback on fit, feel free to grab it. If you have a harness that maybe you have a question about and you can show it to the camera, I'll be happy to look at that too during that time. But that's kind of the upcoming part of what's going on. But definitely need to teach people how to use them correctly. A harness that is ill fit is often almost as dangerous as no harness. So we want to make sure we get these people fit properly in the harnesses. And I'll put one on, demonstrate how to put it on, the whole 9 yards here in the second half. All right. Fall protection training. Employers are required to train to the natures of fall hazards in their work area, correct procedures, again, maintaining, erecting, disassembling and inspecting guardrails, floor covers, any of that sort of stuff. Also, the role each employee has in the fall protection system used. So that just has to continue with training. Employers train employees on the limitations during performance of, say, low slope roof work, correct procedures for handling and storage of the equipment. What do they do with the harnesses, right? If I go out to a job site and I open a toolbox or a gang box, am I going to find the harness on the bottom underneath the sawzall and circular saw and all that sort of stuff? So they just grab at it and yank it and then run that fall protection harness right across that blade. So it's going to get nicked up and cut up. Or is it hung properly? Or does it have its own bag or its own bucket storage system? Is it riding around in the back of the truck getting rusty, right? Out in the rain, out in the heat, out in the cold, all that sort of stuff. That's what we need to make sure we're doing as well. And what roles employees play in the fall protection plans. Again, this has to be written certification. So it's one of the few times OSHA uses the word certified. When somebody says it needs to be certified by OSHA, you know they don't know what they're talking about because OSHA doesn't certify anything. But they do require certain certifications. And this is an employer certification stating that they have made all the training parts of 1926-503. And that's what I'm reading right now. All these parts are found right in 1926-503. So if you Google that, OSHA 1926-503, this is what you'll see. Date of employee trained, date of training, signature of person conducting the training, latest training certificate must be maintained. Retrain employees whenever they believe the employees receive changes or they believe that it's necessary. Good rule of thumb, if you're working at height all the time, do your fall protection training. Maybe you're going to do another full fall protection training in 2 years, but do some toolbox talks, do some other trainings at least, every quarter, every 6 months, something like that, just to keep their mind jogged on what they're supposed to do when it comes to fall protection. But OSHA doesn't tell you have to do it every year. OSHA doesn't tell you it's a one-time and done thing. They leave it up to you. OSHA writes what they call performance standards, which they're going to tell you what needs to be done, and it's up to you to figure out how to get there. So that's important to know as well. Competent person responsibilities, right? Again, identify existing and predictable hazards, authority to eliminate the fall hazards, authority to stop work, has authorization to take prompt, immediate action. If OSHA comes up to you and they point out and they go, do you see that roof over there with the person on it? Isn't that your employee? If they fall, couldn't they get hurt? And you sit there and hesitate and go, well, let me call the office and see what they want me to do. You are not the competent person, right? When they say, do you see that person? That's when you march and you go take care of that person. That's competent person. That's what you're supposed to be doing. So qualified person. So they're going to ask about qualified person. Qualified person still has to have that background training and experience. They have to have an extensive knowledge of what they're going to be the qualified person on: fall protection, scaffolding, crane operations, whatever it may be. The big difference is they don't have the authority to take immediate corrective action. So your qualified person is usually going to be the person who writes the program or writes the fall protection program or whatever. But the competent person is the one that carries it out. I hope that makes sense that way. Could they be the same person? Definitely. But usually they talk about the qualified person. Like if you called me and said, hey, I need a program. Can you work with us to do the program? Can you be my competent person? No, I don't work for you. I don't have the authority to stop work, any of that sort of stuff. But I can help you as the qualified person to help you write a program. Okay. I can't carry it out for you. You need boots on the ground to do that. I can't do that part for you. So qualified person's also going to be taking a look and maybe supervising how anchor points are put in. But they don't really have the authority to stop work. They need the competent person for that. Questions so far? We're going to touch a lot more on this as we go. We're getting into ladders. Everybody uses ladders, right? I have those same disclaimers up front here. We want you to be able to use them correctly. Anybody on this web chat ever fall off of a ladder before? I have. I can tell you It hurts. Okay. What type of ladder was it? Somebody said yes. I've fallen off of both. What was it?
This is a 12-foot, 16-foot ladder.
Ooh, okay. And what happened?
Well, it was leaning against the A-frame. Problem was I didn't see it was sitting in a hose, so that didn't really. The ladder slid out from underneath me.
Oh my, gotcha.
It did bang up my elbow.
Banged your elbow up, but you're still with us, so that's at least good. That's a lucky point right there. Yeah, and it goes quick. It's not like you have much time. Once it starts to go, it's gone. So,
happened for a minute.
Ladders, you've got to be careful with ladders, and we're going to go through all that. We're going to talk about proper ladders to use based on the conditions, also capacity, height, proper pitch, right? And then how do you maintain safe position? So what do we have here in this picture? We got a job built ladder. It's a double gang ladder, which means you can go up and come down as you want. Remember, when we have multiple employees on a level, we need to give them access so they can get up while the other one's coming down. So perhaps the way they did that on this one was a job built ladder. Is this legal? Sure it is, as long as it's built properly. And we'll give you the way to build this properly in a few minutes. I got somebody chatting back there. I'm just going to mute a few of you that have your mics open. Just go ahead and open your mic when you're ready to talk to us, but just want to get rid of the background noise there. So each employee using ladders should be trained to recognize the hazards, nature of fall hazards in the work area, correct procedure for placement, etc. We'll get through that. Is this a ladder or a scaffold? I'm curious. That's impressive, isn't it? That's 3 buckets high. How many people can step up 3 buckets, right? There's no such thing as a OSHA approved bucket ladder or bucket scaffold. That's no good right here. How did he even get up there? I mean, that takes a serious like jump to get up there, I guess. Scary all the way around. Why would you do that? Because the ladder's not near you. I mean, ladders aren't that expensive. Go find a ladder, right? Get rid of this out there. Before you get on the ladder, you got to think about what would this ladder hold, right? Is it too tall or too long? Condition of the ladder. OSHA is pretty simple. Use the ladder the way they're intended to be used and don't go beyond the maximum intended load. Use them as the manufacturer tells you to use them. And some manufacturers have really changed the ladder game here in the last couple of years. And we'll look at a few of those too. How much do these things weigh, right? Plywood, window, 5 gallons of material, bundle of shingles. You know, back when I was doing a little bit of work with my dad on residential, you know, you threw 2 bundles of shingles on your shoulder and went up the ladder and put it on the roof. That's 140 pounds plus your weight. Did the ladder hold what we were asking? It held most of the time, but it was crying. It was well beyond capacity. I guarantee you that. Think about using a haul line to bring stuff up, or even get a delivery to the roof rather than carrying it up yourself. Use ladder vaders. There's some different ways to get materials up there now that wasn't there 20 plus years ago. Here's our ratings. If you've never looked at the side of the ladder, right? 1 AA all the way down to a type 3 ladder. Type 3, what does that say? Right there. Household. That's where it needs to stay. All right. Anything household needs to stay home, not on the construction site. My drywallers, painters, they're constantly getting these little cheap ladders. They're light, they're cheap. That's why they carry them around, but they get beat up pretty quick. So get rid of that stuff. So we start 225 and above. 225, I'm already maxing that out myself. So if I'm getting on the ladder, I got to figure out, will this hold me? Will it hold the tools that I'm going to carry up it? What about the materials that I'm going to have, right? So I got to look at all of that when I consider what ladder I'm actually going to use. When I set an extension ladder up, if I'm getting off that extension ladder, those rails have to go 3 foot above. How do I tell? I've got 3 clear rungs right here, right? 1, 2, 3. So I know that's 3 foot above. So that gives me that section to step off onto the roof while holding that ladder and go where I'm going to go, or tie off, or whatever I'm going to do. If I'm underneath this, that doesn't allow me that. How many of us have ever put the ladder up against the building and it didn't quite reach, but we went up anyway, right? I've done that. And going up's not the problem. You can climb up there pretty good. It's that coming down where you have to fish with your foot and hope you're over top of where your ladder was and it doesn't kick out. That's where things get to be a little difficult, a little challenging. So we got to have those 3 foot above. Some people don't like the rungs being in the way, so they'll use the hook on platform like this, so they can actually walk between the uprights. So I still have my 3 foot, but I can actually walk in between it rather than go around it. So it's kind of what you're into there, whatever works for you and your crew. 3 foot above is the rule if we're getting on or off the ladder. If I need to figure out how long of a ladder, and this little thing right here, a lot of people will take pictures of this little chart and then post it right next to where their ladders are. So if somebody comes into the shop and they think, hey, I need to get on a roof that's 26 feet tall, what size ladder do I need? Well, 26 falls right here. A lot of people will go, I need a 29 or a 30 foot ladder. I need that 3 foot above. But they forget about overlap, and they forget about the 4-to-1 angle, right? Every 4 feet I go up, I got to pull it back a foot so I get that proper angle on my ladder. So if I'm going up 26 feet, I need to have a 36-foot ladder. So sometimes people take the picture of this chart, again, put it right next to where their extension ladders are. And when somebody comes in, they can just look over and say, hey, I know I'm going up to X. Oh, I need this size ladder, and take it with them. So just an idea for you. This whole presentation will be available, by the way, if anybody wants to see parts, pieces of it, or use it under the Hardwick grant, and I'll show you where that stuff is later. Step ladders, rule of thumb. What's the height that I need to get to? Say I'm going up 12 feet. then I subtract 4 feet, and that's the proper ladder height that I should take. So if I'm going up 12 feet, I take away 4, I'm at 8 feet. I shouldn't have 6-foot ladders with me. I should have 8 and 10-foot ladders. And what that would do is keep me 2 feet down or 2 rungs down on the ladder as I go through. Did you have something, Patrick? Oh, okay.
No,
Sorry.
I'm good. Thank you.
Nope, you're good. Inspect your ladder. Prior to each use, inspect your ladder. Is it damaged? Is it cracked? Do we have the old wobbly ladder? I call them old rickety, and we'll talk about old rickety here in a minute. If it is damaged or broken, tag it out of service. The problem with tagging a ladder is a lot like throwing away the ladder, right? Has anybody ever thrown away a step ladder? I bet by the time you throw it in the dumpster, you turn around and you head right back to the project. That ladder has beat you from the dumpster right back out to the project. You see it again. People see it. Oh, it's still usable. They're taking it back. If you're going to take a ladder out of service, destroy the ladder or get rid of it. You put a tag on it. Yes, people should look at the tag and not use it. But let's be serious. It's 2:30 on a Friday, and they have to do one thing, and your ladder's laying there with a tag. They open it up. They're on it when OSHA walks in. Guess what? That serious violation just became a willful violation, right? Because now they knew what they did, and they still did it anyways. So you went from a $13,494 citation to a $134,937 citation. Tags are great when they're used. Tags are not great when you tag it out and then you're still using it. Don't allow that to happen. Inspection of ladders. Here's all the different things you want to look at. Missing rungs, broken, damaged feet, loose nails, bolts, rivets, the spreader bars, rot and decay of wooden ladders, cracked, split, worn, broken rails. Get with your ladder manufacturer. A lot of them will have an inspection form that you can get or download directly from their website, like the Warners and the Little Giants and stuff like that. And they'll talk to you also about lamination when that ladder's, pale and doesn't have that shiny coat anymore. That if it's a fiberglass ladder, that can actually deal with some of its serviceability. So get to know that stuff. If you're the competent person when it comes to inspecting ladders, you need to look for all of this. Here's that ANSI standard, right? So if I take a look at this, job built ladder, what's my side rail need to be? 2x6. And if I read through that standard, it's also going to tell me about knot holes, how close they can be to the edge, how big they can be in that entire piece of 2x6. And then the 2x4 rungs with 2x2 fillers. And it even tells me what size nails I need to use, right? And my maximum distance is 24 feet. So again, if you want a job build a ladder, as long as it's these specifications, ANSI's good with it. OSHA's good with it. But how long is it going to take you to build this ladder, and what's it going to cost you versus going to a Home Depot or a Lowe's and getting a good extension ladder that you'll take from site to site to site? How many of you see this in a ladder rack going down the road? I don't ever see this in a ladder rack, right? It gets chucked at the end of the job. So if we just get the proper ladder and we take it, we can take it from job to job. We'll save money that way. What the heck is this? Why would you do this? Why would you put the 2x4s on the outside? Oh, I see. They've got a broken foot right here, right? And this one's already cracked, so they put a little filler in here too. You can't job modify a ladder. I always say this is old Yeller. We couldn't get rid of it. It's made us a lot of money. We couldn't possibly part with it, so we fixed it. Well, that's not a good fix. In fact, if OSHA saw that, that's a serious citation right there. So for $13,000, I think you can buy a lot more ladders than just one step ladder. So get rid of it, get something new. How much of a dent is too much of a dent in a rolled form type ladder? So any of these things like a scaffold or these hollow aluminum ladders that have the fill, whenever you get a little dent, that's where your failure point's going to be, right? Whenever that dent pops in of that rigid pole or rigid form, you dent that, you've taken away some of its structural integrity. How much did you take away? The only way to know is to send it to a testing lab and crumple it to find out. If you get a dent like that, it's got to go. You got a dented scaffold, it's got to go. You overload that, that's where it's going to crumple. You just put a weak point in it, so you got to get rid of that. Ladder labels. see ladder labels all the time are an issue for people. They ride around on the top of the truck. We're using them outside. We use them in the rain, use them in the sun. We use them all over the place. Labels fade, labels peel. You don't throw away the ladder just because of the label. You can contact the manufacturer, buy a stack of labels, and every time one starts to get worn, put a new label on it. All right, just make sure you have it for that ladder. So it doesn't matter, again, if it's a Warner, Little Giant, Lynn ladder, any of those, they have labels. You can buy replacement labels. Avoid setting a ladder up in high traffic areas. Have you ever opened up a door and you hear somebody on the other side, whoop, whoop, whoop? You know, they're on the other side painting or doing whatever. They didn't put a sign over there. So what stops them from getting knocked off that ladder? We got to think about that stuff when we set our ladder up. What's going to happen in this area? How do I protect myself from the traffic in this area? Don't use metal or aluminum ladders near electric lines. Remember, you got to have that 10-foot distance, right? If you get closer to that 10-foot distance, it can arc over, find that ladder, and kill you. I know this will be a good question for Virginia OSHA, but for a few years, every time we had them out to chat, we'd have at least a homeowner or a tree trimmer or somebody that would put a metal ladder up in a tree where power lines were touching it right after a rainstorm, and then they touch the ladder and it kills them. So we got to think about this stuff. Electricity will flow through that pretty quick, and it'll go through you even quicker. Ladders need to be placed on stable level surfaces at 4-to-1. So if I put my feet straight at the bottom, arms straight out, I should be able to grab rung or rail. That's 4-to-1. All right. The whole idea, if you look at the way the rungs are set up at 4-to-1, those rungs are flat. That ladder takes the whole load and puts into the feet when it's at 4-to-1. If it's less than 4-to-1 or more than 4-to-1, then we put stress points on any part of the overlap, and we'll look at that as well. Like this. It's more of a 2-to-1. We can see that ladder already has a bit of a bow, right? Anybody ever take the extension ladder and it doesn't quite go back together anymore? You can slide it maybe halfway, but you can't get it all the way. That's because people are doing stuff like this. And if that doesn't have enough overlap, that can actually click out of these sides and down you go. So that's a problem. 4-to-1 is the proper angle. If you have a smartphone, you can also download the Ladder Leveler app. Click on it, and literally you set your smartphone right on the ladder, and it tells you if you're 4-to-1 or not. It's a free download, but that's there as well. He didn't like himself anyways. Look at the way he cleated that ladder. If he did fall backwards, he's got, double shish kebab getting ready to go through him if he falls. And then what's going on over here?
Not even fully extended, locked in.
Nope, not extended, not locked in. It's just kind of hanging out there. People go, well, I just sat it there. I'm not using it. Is it available for use? Could somebody step on this ladder? That becomes an OSHA citation. So if you bring ladders out to a job site, it's very important. We don't lean them up against anything. We lay them down flat, and a lot of people even chain them together so people can't grab your ladder. Because if your ladder's being in use, you're more than likely going to get a multi-employer worksite citation when they can read the name of your company on the side. So lay it down, lock it up, make sure you control the use of your ladders. Is this a ladder or a job-built stair? I'm not quite sure. Again, we're nailing nails into a little piece of, it looks like 2x, and how close to the edge is it? If you go stomping up there because you're having a bad day, what's going to happen to one of those rungs? It's just going to break through, and you're going to end up in the basement. So no good. Get rid of it. Build it proper if you're going to build it, or put a ladder there. Again, using a step ladder, people go, well, he's not in 3 points of contact. Well, what does subpart X say? Which is the ladder and stair standard. It says when ascending or descending, I have to maintain 3 points of contact. It does not say when I'm working from a ladder, I need to maintain 3 points of contact. So when I'm going up or down, I either use my 2 hands and 2 feet, and I maintain 3 points of contact at all times. Once I'm at my workstation, now I can use my hands. Otherwise, how would you change a light bulb, right? How would you do anything off of a ladder if you have to hold on and only use one hand? It's just not going to work. Here we've got some hybrid ladders. So a while back, we always had a problem with people leaning step ladders. We had a problem with people, using proper ladders improperly. And the big thing about step ladders were back in the day, it had to be on all 4 feet, unless you had like an orchard style 3-point ladder. Then it had to be on all 3 feet to get that weight ratio that you need, or what capacity you can use. When you leaned it up, you put all the weight on half the ladder. So it didn't have those points to spread out that weight. This ladder is a lean safe ladder. And again, Warner has them, Little Giant has them. Trying to think of some of the other manufacturers I've seen, but a lot of them have changed over to having these lean safe ladders to where you can see you've got the rubber grip on the back here. You also have a notch so you can go on like the 2-bys like this gentleman is right here. Of course, he's not wearing a hard hat or safety glasses, but that's beside the point. And then they have extra rubber grips down here. And then you can see they've heavied up their triangular bracing in the ladder itself. So those are some different points that they've kind of came back and said, well, if the problem's leaning the ladder because they're not manufactured to do so, well, let's manufacture them to do so. So they did. Can't do this. What's the problem here? Triangles
Standing on top of the ladder.
Yeah, he's standing right on the top rung.
Yeah.
So if I look at a ladder as a triangle, the further down the triangle, the more sturdy I am. The higher up the triangle toward the tip, the least sturdy I am. So again, I'm on the fulcrum point there to allow that to kick out pretty quick. So that's a problem. What's this right here?
Yeah, it's soft, hanging up on the beam.
Yeah, by its cord. That's called strain relief. So in subpart K, it talks about strain relief for temporary cords, including power tools. That's a citation. We get the same thing here. Check out this nice squiggly cord. Has anybody been to Home Depot or Lowe's lately? If you ever went to the extension cords and found the squiggly cords, how do you make that happen? That's by stretching the cord. That's how that happens. People go, oh, no, that's just us wrapping up the cord. I have cords here that are older than me that were my father's. I guarantee you they've been wrapped up every day, and they don't look like this. When it pulls, the wire will extend. The plastic tries to go back to where it was, and that's what creates that pigtail. All right? So when it starts doing that, you've taken that 16-gauge cord, which is your minimum size cord you should have out there, and you've extended it and pulled the wire so it's not a 16-gauge anymore. So we've had strain relief issues with this cord. It created a problem. Now you're looking at a almost $13,000 fine right there by even having it out on the job site. Get rid of that cord, get a new cord. Watch your ends, watch your insulation. Those are all cord issues. Oh, you gotta love these guys, right? So the guy on the left, backwards, leaning step ladder that is not a lean safe ladder. He's backwards on it. And if you could actually pull out from this picture, imagine him up. He's 3rd, 4th level of this place over top of concrete. So if it slides, he's gone. There's no ifs, ands, or buts about it. And then you have the guy to the right with the household aluminum ladder who looks like he's working in like 16-foot ceilings on like an 8-foot aluminum ladder. And he's, all the way up at top. Again, that's going to kick out. Forget the $13,000 worth of violation just to be on the top of the ladder. Also the $13,000 for the hard hat. But if he falls, what do you think his hospital bill is going to be when he breaks his arm and his shoulder? What's his PT bill going to be? What's the total impact to his family for taking this risk if he falls, right? So go beyond just that it's an OSHA penalty and look at the long-term effect of what's that going to actually do to this person. How long is he going to be out of work, right? No good. Secure and stabilize ladders. If you look at subpart X, it says it needs to secure and stabilize the ladder at the top or bottom to prevent movement. Well, if you can do it at top and bottom, isn't that a better idea? So that's what I usually try to start with. But here's some different ways to do it. You've got a fork tie back that you can use, a chain, a rope. They've candy caned a piece of rebar on the left. Not sure what the looks like a sledgehammer head. It's down here next to this one. But tied this off, that's good. Digging into the ground, which is what you need to do here on the exterior. So this side's good, this side not so good. But then they secured it with the little candy cane there. That's good to go. You see the feet are flipped up. You have a jagged side and a flat side. Jagged side goes down, right? So we flip them up, dig them in, and that keeps that secured in loose soil. If we're on the concrete, again, I've got these rubber pads. If they're in good condition, I got those rubber pads right there that I can flip onto the concrete. Manufacturer says that's one way to secure the bottom. Now, if I have a place to tie it back, should I? Heck yeah. But we don't want to see this. All right. Got to give him, an E for effort on the left there. Look, he's got a 5-in-1 knife on top of a paintbrush and then a paint can on the other side. That's no good. No boxes, no buckets, no other tools. Use the extended legs that you can put on ladders now if you need to do something like this, but this is no good. There's your level lock. There's a couple different manufacturers that do this. There's some ladders that even come with these now. Use them. They work great. Podium type ladders. Some people that are on 6-foot ladders all the time, they just never maintain those 2 feet or the 2 top rungs. They're always sitting on them or something like that. So some people just went to podium ladders. They got rid of the top 2 rungs. You got the tool tray up there, but you're missing those rungs. You can only step on that platform. So very secure type ladder, but gets rid of some of those hassles of having people climb too far up. Then you get up to the safest of the safe type ladders when you get up to podium and cage ladders. So these are actually out there now. Some people are going to, I believe this is not sure the manufacturer, but almost all of them have these now. If I'm going to constantly be working at height, this is a fully functional ladder, and I can adjust the height on both sides. I can even roll the ladder, and it has a big podium cage up here to protect somebody up there so they don't fall off the ladder. So they are really changing the face of ladders now. Here's a multi-use ladder. I can use it straight, like an extension ladder. I can use it leaning if it's like an extension ladder, or I can use it like an A-frame ladder. So again, I just have to go to the manufacturer's data. This is one of those same ladders. They have a ladder leveler leg for all terrain. So really this is set up right over top of a trench, going onto the side here. And it's creating that triangle brace, but maintaining that ladder straight up and down. So probably not the best placement for the ladder, but it is showing the extent that it can be used. So really, really cool stuff coming out when it comes to ladders. Face the ladder when going up or down, keep your body centered. I tell you, if you're on a step ladder, take those bottom 4 points where the feet are, and in your mind, transfer them above you. That's where the core of your body needs to be. It needs to be inside that imaginary box. When your belly button or belt buckle goes outside that imaginary box, that ladder shoots the other way. So we've got to be careful with that. So that's why they say never let your belt buckle pass either of the side rails, because when you're leaning, that's when it's going to kick. 3-point contact when going up or down. 3-point of contact when going up or down. Don't overreach from the ladder. Don't stand on the top 2 rungs. Do not allow another person on the ladder unless it's meant to do so. A double cleated ladder like we saw on the job built ladder. Don't carry anything that's... We got somebody's... I'm going to start muting mics again here. Again, if you're not talking, mute your mic. If you want to talk, that's fine. Just background noise really comes through most of these microphones. Don't stay on the top 2 rungs of the ladder. Use a pulley system to get the materials to where you're going to be. Any questions on ladders? I'll roll right into scaffolds. We'll try to get, again, at the end of this section or close to it, we'll take a break, and then we'll do the second half of the class after that break. All right, learning objectives.
And I had a question.
Pretty much, yeah.
Let me see if I can phrase this right. So we have an issue a lot of times where guys drill into the top plastic piece of an A-frame ladder,
Okay.
makeshift hangers, things like that. And we always, or at least me, I tag those ladders out, but I get a lot of kickback saying that that's what that top piece is made for. And is there anywhere that I could, you don't have to answer it now, maybe later, but is there anywhere where I can find literature that says that you cannot drill any type of screw into the top frame of a ladder. Usually I can't find it with the manufacturer, but maybe I'm not looking hard enough. I don't know.
I would actually call the manufacturer because I've had this in the past, and I called. Actually, that one was on a Little Giant, and they drilled into the top of the Little Giant and put a hole in it, just so they could fit their drill in it. Went right back to them, and they came back with a technical bulletin that showed that you cannot modify any part of their ladder. They'll sell you plenty of stuff to modify your ladder, trust me, but they will not allow you to penetrate any part of the ladder or modify any part of the ladder. So that is a manufacturer requirement for all ladder manufacturers. So you're doing right by getting them out, and unless they can come up with proof that they can modify it from the manufacturer, you're right on that one. You're definitely right on that one.
All right, 10-4. Thanks, Matt.
Yep. So, section 3, we're going to talk about scaffold here. Again, general requirements for scaffolding. Again, we're going to need that competent person, qualified person. We'll talk about that. Capacities, proper fall protection, safety requirements for the different types. So let's get into it. Residential, here's a basic type of scaffold. It's a pretty decent looking scaffold. They've got their cross braces. They've got their guardrails complete. They've got a hook on ladder system. So a lot of you that like the built-in ladders, the problem with built-in ladders, most of the time we're overlapping our boards, right? So we have that board that minimum of 6 inches, no more than 12 inches. We're going to push ourselves over and climb over it. Well, why don't we use a hook on ladder system that goes right in the middle somewhere? And now I can climb the exterior. I don't have to dodge and go over anything. The only hazardous part is when I get on to, say, that second level or the fourth level, I have to dive through the rail. That's acceptable. But it's definitely sometimes safer than having that in rail. And we'll get into it coming up, but it also goes back to, will they use the access point you gave them? And we'll kind of play that game here in a few minutes as well. 3 basic types of scaffold: supported scaffold, suspended scaffold, and aerial lifts. So we'll talk about each one of those. Supported scaffolds themselves, if you go to subpart L, it breaks it into A through Z, so 26 different types. There's literally hundreds of types of scaffolds out there. You need to be competent on the one that you're using, or the 3 that you're using, or whatever. Most of the time when I'm dealing with a client, we deal with scaffold. The first thing I ask them, who's the manufacturer? All right, think about your scaffold. Can you tell me who the manufacturer is? If you can't tell me who the manufacturer is, don't raise your hand when I say, are you the competent person? Because how do you know what the manufacturer is actually looking for if you don't know who they are? So sometimes it's so rusted that you can't even tell what color it was, but sometimes they'll say whoever builds the blue scaffold or the red scaffold or whatever, and multiple manufacturers might use multiple colors. So you really need to know what the standard is for your scaffold. Competent person requirements. Again, any of these things are going to require a competent person designated by the employer, knowledge and experience to know that scaffold from one side to the other, authority to eliminate hazards, authority to stop work if need be. Competent person will usually train the employees who erect, dismantle, move, or alter scaffolds and work on scaffolds, determine if it's safe for employees to work on scaffold, especially during, say, storms or high winds. How close is too close when working on a metal scaffold for lightning, right? Have you set that in your safety program? You got to think about these things. The great thing about now versus 20 some years ago, when I started in safety, we had to look at wind socks and call someplace to get the weather. Now we glance down at our phone and we can get the weather, right? And we can find out what the wind speed is and all that at a glance. There's also things like lightning bug and some other weather type devices, weather alert devices, that you can sign up for and tell you, hey, if lightning's within 10 miles, text me. If winds are going to get over 20 miles an hour, text me. So you can get some of those alerts as well. But you need to make sure that somebody's there watching this stuff, because we're going to have windy days and there's going to be lightning storms. So how close is too close? It's not just hurry up and work faster. It's work smarter and don't get yourself into that situation. They're also going to be the ones that inspect the work scaffolds visible before each work shift. If I'm working multiple shifts, I have to have multiple competent people, because if they're going to get on that scaffold, somebody from my company has to walk through as the competent person and check and make sure, are my uplift pins there? Are my rails straight? Did anybody modify this scaffold before I get on it? Take a look at this one right here. Do you think a competent person inspected that? We have the nice deformed bear there. Somebody dented the snot out of that. And then they took a piece of metal strap, put across the top, put the walk boards on top of that. And where's the cross braces? Look at this thing. I mean, there's no cross braces on the front or the back. What is holding this scaffold up? Right? We move that weight. We put an impact to the side here. That scaffold's going over. So that's completely wrong. Again, if you want to see the top of the top, there you go. That looks really good, but let's look at more real life stuff. Here is a pump jack scaffold. Here's a proper pump jack scaffold. Anybody in residential that uses pump jacks, take note of this. Intermediate triangular brace, end rails, actual end rails, not whatever they kind of put together. Mid rail. I mean, that's apple pie order. Biggest problem you have here, 4 steps or 30 inches, you got to have a handrail. So siding person's going to be fine, but the builder on this site might have an issue with OSHA if they walk through because they don't have that access blocked or they don't have rails up. So got to watch out for that. Ladder jack scaffolds. Anybody use ladder jack scaffolds out there? The biggest part to know about ladder jack scaffolds is read the manufacturer's data on the actual ladder jack. It's going to tell you what size ladder and what capacity that ladder needs to be. All too often, if I do see these out there, they're on light duty or the lowest commercial duty, like a class 2 ladder or something like that. And they're way overrated, and they're telling you got to be on a 1A or something like that. You got to use what the manufacturer tells you have to use. This also requires you to incorporate fall protection. So we'll see that in a minute. Interior mobile scaffold. Some of these will allow you to go up to 10 feet without fall protection. Read that little label there and that little label there. Some will say you need fall protection from the ground up or 4 feet or more. Read that manufacturer's specification and do so. OSHA tells you with scaffolding, 10 feet or more, you got to have guardrails. Now, we just talked about 10% of the fatalities were under 6 feet. Now they're giving you a 10-foot running head start to fall. Again, it's just a minimum set of standards. It's up to you to see what the employer wants, and on this, the manufacturer wants. Manufacturer standards can be cited under 5A, the general duty clause. So if you're using I learned this a long time ago, an east wing hammer, what does it say on the side? Got to wear goggles. Plumb hammer, what's it say? Got to wear safety glasses. That's why I switched from east wing to plumb, to be honest with you, because I can wear safety glasses, but I'm not going to probably wear goggles all day. So that was a choice I made. Same thing with these rolling scaffolds. Some say 4 feet, some say at all times, some say 10 feet or above. I have to have those rails. Make sure you know what yours says. If we're using this, first thing we're checking, casters. Make sure the casters are locked, right? Look at the floor. Make sure there's no immediate changes in elevation. A little dip in the floor or a little cutout, one wheel goes in that, it pitches the whole scaffold. So we got to be careful of that. Trestle scaffolds. How many people use trestle scaffolds? I see a lot of people use the ladder portion, right? This is meant to be used in a scaffold format. So I push the interior, what looks like a ladder, up to my height. I put my walkboard across it, and then I have another ladder to access the trestle itself. So that's a trestle scaffold. Exterior top plate scaffold. Again, if I'm working on walls and I'm getting ready to set trusses, the old days of walking the top plate are just, not acceptable anymore. So maybe I use a top plate scaffold, or I turn around and use those ladders inside, or a rolling scaffold inside to set them. If I'm on the outside of the building and the trusses collapse, I've got a pretty good idea that I'm going to be stuck to this side. I can get a ladder up there and I can get rescued pretty easy. If I'm inside and the trusses come down, there's a good likelihood that there's going to be a lot of injuries to the people inside. So that's why they're looking at other ways to do some of these tasks. Job built scaffold. You can job build, but you got to make sure it's per the proper guidelines. Just like that ANSI guideline for a job built ladder, they have one for sawhorse scaffold. So if you build it per the ANSI standard, okay, you can use it. But if you build it and something goes wrong, it's back on you. If you buy it and you use it the way the manufacturer tells you to, and something goes wrong, at least you have the manufacturer to go back to. So make sure you follow all manufacturer's instructions. Common hazards when it comes to scaffold: defective planks, unsafe access, inadequate footing, inadequate cross bracing, bridging of scaffold. Bridging a scaffold means I have one scaffold platform going this way, I have one going this way, and then I put a little walkboard in between, right? So I've got scaffold A and scaffold B with a little walkboard. If one flips over, it can take the other one over. I can't do that unless I use put logs to turn that all into one scaffold. So bridging of scaffold is a big no-no. Again, working within 10 feet of those power lines, right? We have to look at that. How do we know how much juice is coming through the power line? You don't just test it, right? You don't want to do anything with that. You go to the power pole, call the power company, go to the power pole. Most of them have an identification tag. You can tell them where you're working and what that tag number is, and they can tell you approximately what's going through that. Because if it's over, was it 60 kW, you've got a lot more than that going, then you have to have a bigger area than just that 10 feet. So 10 feet's the base, and then we got to figure out how much juice is flowing and how we get close to it. If you're working on a building that has power lines going along and you have to get up there where the power lines are with scaffold, they either need to shut down the power lines, they can put on the insulation, proper insulation to the power line, but we need to make that safe before you get up there. It can't be we just do it as carefully as possible. Those days are gone. Excuse me, sorry. Training requirements: anybody who's getting on or around a scaffold needs to be trained. Okay. And there's different levels of training. Qualified person must conduct the training, and it needs to include those electrical hazards, fall protection, falling object protection, proper use, material handling, and load carrying capabilities. Every time I go up to scaffold and I see people working on it, I'll ask them, hey, how much can that scaffold hold? Almost all too often, it's like I'm talking to Scooby-Doo. Right? That's a bit of a problem. They need to know, what's the maximum capacity? What can I put on that? What does a cube of block weigh? What does a cube of brick weigh, right? That we're putting on that scaffold. Am I overloading that scaffold? Because the scaffold has to hold 4 times the intended load. So if I put a 250-pound person on it, scaffold already has to hold 1,000 pounds. If I put a 1,000-pound cube of block on it, then it needs to hold 4,000 pounds without anybody else there. So we've got to be careful with that. 10 feet or more has to have guardrails or other means of fall protection. Competent person must supervise setup and takedown of all scaffold. That's another one I get people on all the time on residential and commercial sites. Go over to the scaffold. Who's your competent person? We start walking the scaffold a little bit, and the competent person, well, I didn't even see that they set this up. Well, there's a problem right there. You're the competent person. You're supposed to watch them set this up. You're supposed to make sure it's safe from the get-go. Scaffold must be fully planked. Planks must be secured. We'll also run into people using somebody else's scaffold. Oh, well, their competent person checked it. Nope, not good enough. You get on the scaffold, you own that scaffold. It can be put up by anybody. You can pay a company to come out and put it up. The scaffold resources and the UBSs and all those different scaffold builders can come up and build you the nicest scaffold in the world. But who's going to check it prior to every shift? Because it's not up to them to check that. It's up to you, the user. All right. When you get on it, you bought it. Under multi-employer worksite rules, it's missing rails, it's missing something, and you're on it, you bought that violation. They may also get that violation, but you bought that violation. You're exposed to it, right? So erect them per the manufacturer standards, inspect them per the manufacturer standards. Again, it has to hold 4 times the intended load. Stable footing, that can be base plate, screw jacks, but usually we use mud sills if it's not on concrete. Anytime you have a scaffold tube, you have to have something in that tube. So there has to be a bearer in that tube. A lot of times if you're working with masons and stuff like that, they just take a piece of angle that had a piece of steel and set it in there. That's not good enough. It needs to be per the manufacturer. You're holding that tube to keep it structurally sound. You can't just set it on anything. Scaffolds must be able to hold 4 times the intended load. Workers, equipment, tools, material. We got to take all that into consideration, right? Front edge must be within 14 inches of the face of the work, especially if we're using outriggers. So it gives us some room to do that overhand bricklaying or block laying or whatever. But still, there's an area there that you could fall. You got to be careful of that, and you've got to put your end rails, especially on your outriggers there. 6 to 12 inches. If it's 6 inches or if it's close, we need to cleat. Why are we cleating it? just every day working on a scaffold is going to allow those boards to move a little bit backwards and forwards. If we cleat it, it's not going to move. If we put a load on something and it starts to bend, we're actually taking away, right? If I'm here and it starts to bend, I start to slide down, right? If I cleat it, it's going to hold it in place. So if I start to overload it, it's not going to allow that board to just slip out. So we need to cleat 6 inches or less, no more than 12 inches. Why no more than 12? Because then we start making that walk plank. If it's out 2 feet and somebody needs to get out to that edge, but it's only for 5 minutes, you know they're going to climb out to that edge. And if nobody's on the other side, that goes down, they hit the ground. So that's why you got the 6 to 12 inches. Base plates. These base plates, this is a screw jack base plate. It has 4 holes. You're not going to find, except in the manufacturer standards, where it has to be pinned on both corners. But what happens with the scaffold is as we're working on it, it starts moving, right? And if it moves off to the edge, it can slip and fall. And if it falls off the edge of its mud sill or whatever it's sitting on, you have a pipe with a stacking pin. You have another pipe on top. And if you don't have an uplift pin in there and it falls, it may not come right back on top of it and you get a scaffold collapse. If it gets bumped with a forklift, again, you can have that same thing happen and you get a scaffold collapse. So when you look at this, the best data that I got was from the governing body over scaffold is the Access Industry Association. And they tell you base plates should be at least 10 inches wide, so 9.5 inches, so 10 inches nominal. And then from 9.5 inches from the center of the bear out both ways. So basically 10 by 24 is your minimum mud sill. All right. It should be sitting in the center and have opposite pins nailed in and bent over, whatever, to secure that foot so it doesn't walk off. This is not allowable. Never have masonry product, all right, underneath your scaffold bearers. That's a problem. What happens with that center block? Have you ever watched a mason break a center block with a hammer? They go tink, 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 smack, and it just breaks that cell right where they wanted to break it, right? What do you think that scaffold's doing while it's working on there? It's just going to end up crushing that. And again, you're going to drop. And what's that going to do to the rest of the scaffold? It's going to collapse. So don't want to see that. Each platform must be fully planked. So that's front to back. No more than 1 inch of space in between. Wood planks must be at least 2x10s, must be scaffold grade planks or equivalent. When you see OSHA stamped on the side, that doesn't mean OSHA inspected these planks. That just means it meets the standard. Okay. I've had people before, they I had to get these OSHA certified planks, so I had to buy all these from wherever. OSHA doesn't certify anything. It just meets the standard. Scaffold grade planks or equivalent. Well, what do I find out equivalent? Go back to my manufacturer. What do they expect me to use? Access, if it's more than 2 feet to get up on the scaffold, I need to have proper access. Don't climb the cross braces. Place the ladders so they're secured and they will not tip the scaffold. OSHA permits direct access from one scaffold or structure to the scaffold. So if I run a scaffold this way and a scaffold this way, I don't need to put that bridge across. If I butt them up close to each other, I can step from one to the other. Okay. If it's no more than a 12-inch up or down step, I can go right up to the roof off the scaffold or whatever that may be. All right. Ladders. Again, we talked about making sure it's more than just compliance, that they'll actually use it. Look at this and just think that the food truck just showed up. How many people are coming down the ladders? All right. Take a look at this person down here. And where's the ladder? There's one that goes above them and one all the way down behind 1, 2, 3, 4 more people. So if I'm going down quick because the lunch truck just showed up, I'm probably just going to sling out and go right down this end of this buck right here. And people go, well, I tell them all the time to use the ladder. That's great. Are you going to enforce that? If we put a hook on ladder right here, you're much more likely to everybody go over and use that hook on ladder to go up or down. This looks great. It looks like it's mostly in compliance, but what's actually going to happen when these people need to go up or down? If I'm here and I'm getting ready to go up here, you know what they're going to do. They're going to throw their outrigger on the front, jump up on that buck, then jump up on the height. They're not going to walk all the way down, come down this ladder, go all the way up, and then go back up that ladder. It's just human nature, right? Take that shortcut. That's where people get hurt, when they take that shortcut. So being the competent person, you gotta think outside of just what's the minimum, OSHA compliance, and think about, if I'm using this every day, how am I going to do this to where it makes sense and my people are more likely going to stay in compliance, right? So top rails on a scaffold between 38 and 45 inches high. They need to hold 200 pounds downward or outward force. Cross bracing can be used as the mid rail. Again, your mid rail is going to be down there halfway in between. So it's between 20 and 30 inches is where your mid rail needs to be. If the center of your cross brace is between that 38 and 48, I can use that as my top rail. If the center of that cross brace is down there between the 20 and 30, I use it as my mid rail. Then I just have to add one more rail. They actually state right in subpart L, all workers on scaffolds must wear hard hats. All right. It's pretty much true for any part of construction, right? Whenever it is, or is potential for flying debris or overhead impact or side impact to your head. When's that in construction? Pretty much all the time. But scaffold lays it out completely that you must wear hard hats. Again, here you go. Pretty decent, right? Cross bracing is being used as the top rail. Got the hook on ladder system going all the way up. They even have a pulley system up here. Everybody working here has a hard hat on, so looks pretty good. Again, we don't want to see that. No good. What the heck is going on here? What do you do when you show up to the job site and you see this? Do you suddenly think, I think I have a meeting. I'm going to leave and I'll come back? That's pretty rough looking stuff here. We have a set of scaffold bucks with one cross brace. So that's already no good. We have some kind of pallet being chalked up here to help catch this load. I mean, we've got another set of scaffold that's up over top, and it's not even over top the bears of the other scaffold. That's just horrible scaffolding. We need to definitely stop what's going on here, figure out who the competent person is, get all this junk down, and put in proper scaffold if they're going to use scaffolding. Oh, check this guy out. 4 times the intended load. If I put 3 of his buddies up there, what do you think is going to happen with that walkboard?
Snap.
Yeah, it's going to collapse. That's right. The other thing we use, so rule of thumb, is 1 in 60. So no more than 1 inch of deflection in 60 inches. We have went beyond that. So we have a scaffold system here, and what you can't really see is we have a ladder here, and they just put the walkboard across. No go. That is no good. Also, no hard hat, right? No good. Oh boy. We also don't add to our ladder height. So unless we have what we nickname the dance floor, whenever we take the floor here, like in an auditorium or something, and we raise the entire floor and we work up there, then we can work on other scaffolds and ladders if the manufacturer allows us. We can never, on a regular platform ladder, put anything to increase our height. We can't use a ladder. We can't use sawhorses like this guy's using. I mean, that's just... You can tell it's not his first rodeo, though, can't you? I mean, he's done this more than once. He came prepared to the game this way. No good. What's wrong with this scaffold? Again, we're missing our cross braces up front. We're not fully planked. Again, fully planked means from this point right here, right, to this point right here, we have all wood planking going across. We don't have our 12 inches of overlap. We have something going on over here. I mean, we're just missing all the way around on this, so no good. Okay, well, we fixed something earlier. Remember the guy on the 3 buckets? This guy's figured out that if he stacks the buckets together and puts a wood beam across it, it becomes a scaffold, I guess? No, this isn't any good either. So again, we've got a decent walkboard, but we don't have the scaffold. We also don't have a hard hat, right? We don't have glasses. We're right above our face with drywall mud. So all that stuff's no good. What do we have going on here? Again, we have not only cinder block under the scaffold, but look at how much cinder block we have. And we have an excavation, open excavation. All excavations will fail, just give them enough time, right? There's nothing holding back that soil. And 3 foot by 3 foot by 3 foot of soil, a cubic yard of soil falling in at 6 feet, hits you basically at the same impact as a vehicle at 30 miles an hour. What's it going to do to that block? It's just going to explode that block and tip that whole scaffold over. So if it tips that whole scaffold over, you're chucking everybody up top, and everybody around is in danger. Plus, you had somebody down in that trench to stack all that center block anyways. So this is no good from the ground up. This is horrible. Oh, nice. I can tell you that's insulator just by looking at it. So insulator put himself a ladder up there, put a walk plank across, and is walking that plank back and forth, stuffing all the insulation in. No good. No good on so many levels here, right? What's this guy thinking, right? How bad of a day does he really want to have? If his ankle gives out, if his boot is slick, if there's a little dew on that metal and he slips, what's his best case scenario? He's going to fall and hit 3, 4, 5 braces? What is his best case scenario? Because his worst case scenario is he's going to be dead. Or he's going to be, broken neck, broken back, paraplegic, quadriplegic, right? His whole day is going to change because of a bad idea. His common sense button is stuck. And this is the kind of stuff that you need to call a timeout and talk to this person and go, man, there's a better way. We just got to figure out what it is. Can we use a ladder there maybe? Could we rearrange that scaffold to where we actually have a work platform up there? Because that's just no good the way it is. Just because it says OSHA board on the side of it does not mean that it's always going to be a good board. We get cracks. We got to go back to the manufacturer. What type of board is it? Is it metal reinforced? Is it a composite board? Is it 6 inches? Is it 16 inches? That's kind of the range that some of those allow a hairline crack, much less being split almost in two. And how many times do they take the cutoff saw up there and cut the brick and block on the scaffold, and they start cutting the bucks or start cutting the boards too? A little cut takes it out of service, right? Get rid of it. Woof, look at those boards. Not even 6-inch overlap. Shoot, not even fully planked. And the planks that they do have there are rotten. They got chunks missing out of them, right? Check out this this cross bearer right here. It's bent, right? It's bent right there. All that stuff needs to go. And they don't have cross braces again. I don't know what people have against cross braces being on the front and back of a scaffold, but we definitely see a good bit of that. What is going on here? Looks like they're building something, right? They must be building like a structure for the window. I'm just not sure what they're doing. Nobody would ever get out there, right? Oh, yeah, they will. All right. They built themselves a little work platform, a little job-built scaffolding. Any of those 18 inches wide, what will they hold? When will they fail, right? Got the ball cap underneath the hard hat. How did he even get up there? Where's the ladder? He climb off the roof? I mean, this is some dangerous stuff, but you had to get the job done. So that's what they did. Scary. Fully planked, that's what a properly fully planked platform looks like. Add a ladder added to the side in an access route. They're a little off on their cross bracing. They probably need to drop this board down to a mid rail, but they do have cross bracing in the front and back. This one we talked about earlier with the pump jack, apple pie order, that looks good. Here we go with the ladder jacks. Notice he's tied off like he's supposed to be. What's wrong with his harness? Can anybody see anything wrong with that?
It's brought in front of him.
What's that?
It's brought in front of him.
It is in front of him. That's not bad. He's still connected to his back D-ring.
It's too high on his back.
You're exactly right. This part is called the subpelvic strap, or what we call the butt strap, right? That's what you're supposed to sit in if you fall. It's way too high. It's up to his lower back. So that means you're taking all that pressure and you're putting the inside thigh. Got somebody muted somebody there. But but you're going to take all that impact to your interior thigh. If you hold up your thumb, that's about the size of your femoral artery going between your knee and your groin. So if you take an impact to that femoral artery, you could tear that artery and you could bleed out. So we need to make sure we're putting these harnesses correctly. Aerial lifts, boom lifts, fork lifts, right, with cages. All these things are being used out there. How do we know how to use them correctly? Well, first off, we got to be trained, right? We got to meet not only the OSHA standard, but we also have to know the ANSI standard for these things. If I'm using one of these all-terrain forklifts with a built cage, then it has to have a way to properly secure back to that lift. The unit itself must be rated to handle whatever cage I'm going to put on it. So, a lot of times people will buy these things. They'll even buy them at auction or buy them used, and then they put them on whatever forklift they have. Well, that forklift may not be rated for a personnel basket at all. It may be rated for an 8-foot, but you bought a 16-foot. And what's going to happen? So with any of these lifts, what I tell everybody who's going to get on it is we're going to set it on the ground. We're going to run that boom all the way out as far as we can. And I want you to take your finger and walk up to that boom and poke it. And what's going to happen to that machine when it's all the way out and you start poking on that basket? The machine starts doing this. So now we're going to put your full weight in there, bouncing back and forth, and you're going to get a whole lot of sway back and forth. The farther you go out, the more sway you get, right? Anybody ever been on one of these boom lifts and you're driving along on it and you hit a little bump on the road or something like that, or run over a 2x4? And I mean, that thing just jars you. Doesn't matter how far you're out, it jars you. The further you're out, the more it jars you, if not flings you out. So we got to make sure we're attached properly. We got to make sure it's rated for it. We can tell this is an older lift. The older lifts have attachment points here by the waist of the operator. Now they're all down in the bottom by the foot of the operator, because the whole idea is we don't want them to climb up and over the side rail, right? A lot of these baskets will require you to tie back to the boom itself, or it'll have a tie off point inside of here. So, we'll take a look at that as well. Competent person needs to restrict the operation of aerial lifts to trained and authorized personnel only. You can only use commercially built baskets. Follow the ANSI standard for it. Do not use homemade boxes. That's for trash, right? You see the plywood trash boxes? Don't use them on the lift. One of my first fatalities I ever ran, being a safety person 20-some years ago, was in Virginia. They were on an extension forklift, an all-terrain forklift. They were extended out, and it was a guy in the basket, and the basket was a job-built plywood box, trash box, and he was being lifted up to the soffit to finish the soffit on this house. And they couldn't quite get up there, so he yelled at the operator to jump the curb, because there was a curb and stuff there. And when he went to jump the curb, of course, that bounced really hard, and he grabbed the side of the basket. And when he fell, he hit the ground. The basket came on top of him, put the basket and his ribs right through his heart and killed him. By the way, they were brothers. So the operator just lost his brother because of a dumb mistake. One thing that OSHA says is when you're moving the lift, bring the lift down, get the person out, move the lift where it's going to go, put the person back in, and raise them up. If they would have just done that, even with the bad basket, that person may still be here today. But they didn't, right? That's a problem. The other thing is that basket was secured to the lift, with that nylon band that comes out on the plywood and 2x4s and stuff when it comes out in a hack. They had that tied around to tie up the box on the lift. I mean, that's just no good. So we got to make sure they're trained, make sure they use the proper equipment for the job. Here it is, proper forklift. It's attached, secured, person's tied back, good to go. Stand on the floor of the basket. Don't climb up on the edge. Don't use a ladder or anything else to increase your reach. Keep it, again, away from power lines. 50 kilovolts or less, 10 feet. We go over 50 kilovolts, we got to add distance. So make sure you know what the power lines are. And again, remember, that bucket's going to sway. On a windy day, those power lines are going to sway. We don't want to get within that 10 feet with both of them swaying. So we've got to be careful of that sort of stuff. Don't be this guy. What's going on there? Well, thankfully he was knuckled sideways, but he's traveling. He didn't pay attention to this big pile on the ground, right? He bumped against it. One of those big teeth on the tire grabbed that lumber and kind of did one of these numbers, which flipped the lift. And that little bounce flipped him out of the lift, and he's hanging right there by his harness. What are you going to do? You come up on this, what are you going to do? Obviously, if you're a good safety guy, you need to take pictures of it so you can use it in your training class, right? Most people are going to run over and jump on this jump over and run on that scissor lift and go try to rescue him. Well, how long have they been hanging there, right? Because when we get to rescue, we're going to hear about that. That if somebody's been hanging there maybe 15 minutes and we rescue them, we could actually kill them because all of a sudden they've had all these toxins that have been building up in their system for 15 minutes or more released, and that goes up into the liver and the kidneys, overloads those, and they're talking to you. They're happy, 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 and then boom, they're dead, right? Toxic shock sets in, kills them. So we got to be careful. How long have you been up there? Man, I've been hanging here for 15 minutes, 20 minutes. I'm going to call 911. We're going to get you down. You're going to be okay. When I call 911, I need to let them know this person has been hanging in suspension for over 15 minutes. I need a crew out here that can take care of that. That's different than a heart attack, right? That's different than a cut arm or a broken arm for 911. They need to get somebody out there that knows that when they start releasing that person, they need to have IVs in there. They need to release and then put him back into the harness. Release, put him back into the harness. So they only allow certain amounts of toxins, and then they water down those toxins with those IVs, and then we can rescue them safely. This person says, it just happened 2 minutes ago. Come help me. And you're going to help them. Do you know first aid CPR? I mean, yes, I'm going to get that scissor lift over, and I'm going to take the pressure off. But I need to know to start looking at their pants and start looking at their feet to see if there's any blood that starts running, right? Because again, if I punctured that femoral artery, or they punctured it, and I've rescued them, can I get a tourniquet on it or something like that? Because when that thing bleeds out in 5 minutes, that's all you got. So if they're pants and stuff, and we're getting ready to get into the winter season, so they're going to have heavier clothes, are they bleeding out? Check their socks. I always tell them, check your socks, because when they pull it up, you can see if something's running down their leg. Do we need to get something on it to protect them? Do you know first aid CPR? You should, right? I think everybody needs to know it, but OSHA says at least one person on every job. Virginia requires 2, and a couple other states require at least 2 on every job, because just in case it's the person who knows first aid CPR that's having the heart attack, they need somebody else to kick in, right? But how do you rescue that? If you put them at height, you got to figure out how to get them down. It's not just call 911. 911 is part of it, but that's not it. Questions? Right up into our break here. Any questions in the first half? Everybody still with me?
Yes, sir.
So far, so good.
Deal. All right, let's go ahead and we got up to a 30-minute break. I'll be back in 20 minutes. Once we get everybody back, we'll get up and rolling again. But be back by 9:25. That's our maximum, 9:25, and we'll get started on the second half, and we'll get rolling right on through that as well. If you have questions or anything, I'll leave my mic and speaker and stuff on for a few minutes, and I'll be happy to chat with anybody. But go ahead and take your break, make your phone calls, do whatever you got to do, and we'll finish this up. Got about 10 minutes left in our break, but if anybody has any questions or anything, I'll leave mine up so you can ask or chat or whatever you want to do. All right, we'll get started back in just a minute. So if everybody wants to get back to their computers and get everything set up, and again, if you had any questions from the first half, let me know. If not, here in about a minute, we'll go ahead and just get rolling into the second half. How's the pace for anybody listening right now? Is it too fast, too slow? I need to speed up, slow down?
I think it's perfect right now.
Doing pretty good.
Perfect. Good deal.
Yeah, I think it's going pretty good. Thank you, sir.
Good deal. All right, so we're going to get into conventional fall protection. Again, we're going to look at some gear I have here and stuff like that during this section, but we'll get right back into it here. Same disclaimers for this section as well. We want to figure out when fall protection is required, types of conventional fall protection. So you have conventional and unconventional. Conventional is anything that's actually going to protect you from falling. Other means of fall protection we can look at as alternative means. They're really last ditch efforts, so to speak. They don't alleviate you from the need to try to keep people safe. You can't just say I don't want to. Okay, that's not a given excuse. But we also need to figure out what system to use for a particular hazard. For instance, I always use hey, if you're working on top of a 6-foot rolling scaffold and somebody tells you got to tie off to something, which if you've got rails around you, you don't, but let's just say you do. You got a 6-foot shock absorbing lanyard, 6 foot a person, that's already 12 feet. So you already hit the floor. And then you have 3.5 foot of shock pack. So you need 18.5 feet to use that 6-foot lanyard. So are we using the proper tool for the proper scenario? So we'll go through some of that in this section as well. And then key requirements and basic safety practices for the systems that we talk about. So again, when we get to subpart M, which is fall protection in 1926, residential construction sites exposed to vertical drops of 6 feet or more. That's the minimum trigger height when OSHA is going to require you to go into fall protection. Again, state plans can change, but ours do not. Virginia and Maryland does not. Conventional means of fall protection includes a little bit more than this, but for the most part, guardrails, safety nets, and personal fall arrest systems. All right, guardrails, it's a barrier. So if I put on a harness, it protects me, the user of the harness. But if there's 10 of us, I put up a guardrail, that protects all 10 of us from falling in that hole. So we really start there. Can we put that engineering system in place to protect everybody from the hole? If there's a floor penetration, I put a proper cover on that's going to hold that 2 times the intended load. I'm going to secure it. I'm going to mark it properly. Does that protect everybody or just me? It protects everybody. So we start there. If we can do those things, we want to do those first. If we can't, that's when we back into putting in the guardrails or putting in the fall protection system. Guardrail systems need to be 42 and 21. We use them in open windows, unprotected edges, floor holes, etc. All these different items can do it. If we're framing a house and we're framing 24 on center, we have to use guardrails around those walls as well. Because again, that opening is more than 18 inches. So that becomes a wall opening. So we got to go right to guardrails. If it's 16 on center, we don't have to. Still not a bad idea though. I can tell you my 20 plus years, I've done a lot of accident investigations of people falling between the studs on an upper level wall. So it's not a bad idea to put your guardrails up. 42, 21, and a toe board. Toe boards to keep material from falling, right? 42, if we look at the person, 42 is going to come right up to about here. It's above your center of gravity. So when you hit against it, the 42-inch rail, your body's either going to stop and kind of check under or check over. 42, hopefully it starts to check under. That's why we have that 21-inch mid rail, and that kind of captures that, and then in toe board again, so we don't kick a tube of caulk down, or we don't have a pipe, or we don't lose a hammer going down below, right? Vertical supports, if I'm using 2x4s for vertical supports, at least every 8 feet, no more than 8 feet. Why? Because a 8-foot 2x4 is rated to hold that 200 pounds downward or outward force that OSHA requires. 10-foot, 12-foot may not be. Okay, so we need to get those uprights to every 8 foot. And again, 200 pounds applied downward or outward force. We have guardrails here again, 42, 21, and your toe board. We can see that there's an open-sided deck here. They put the rails up, but they've got a big old gap on both sides of the rails there, right? Is that okay? Is that legal? Well, if it's less than 18 inches, yes. And if we go back to that second fatality where the drywall, the guy was sanding the drywall right on the edge, backed off the edge, fell to his death, he wouldn't have needed to take the guardrails down if the guardrails were back, say 14 inches or 16 inches, and they can slide that drywall in place or other materials up there. More than 18 inches because it's 24 on center. We got to put our guardrails up. How's that look? We've got 2 2x4s going across there. But if we look at the floor closely, we can see that that's well over 8 feet, right? So we need to break that up a little bit. So here's using a safety boot system. I don't know if anybody uses safety boots, but this is a pretty good system. Again, you go back to that second fatality. If they would have needed to move this to get the materials up there, they could pick this up out of the safety boot, tie off, get their materials up there, put the rail back, and then they can disconnect and, do the sanding and everything else needed. Again, they didn't go right up to the edge. They left areas for drywall to be installed between the edge here and the face of the wall here, so they could slide that drywall back there and they don't need to pull down the guardrail. So that's a good thing. Here you go. Those rails didn't move. Drywall's up. It's even finished. Don't even have to take the drywall down or the guardrails down. 24 on center again. Put in your rails. Window openings. If there's a 6-foot fall hazard on the other side of the window opening, and again, the window is greater than 18 inches wide, you need to have a guardrail system, right? If it's less than 39 inches, then we need to put in a top rail. If it's less than 21 inches, we need to put in a mid rail, right? Here's a question for you. Guys working on a ladder. Ladder doesn't require fall protection, but we start looking at this. Could this gentleman, as he's coming down, fall through this hole right here? If the answer is yes, shouldn't we put another rail up? Again, if we go to basic compliance 101, until we said, yes, that's a hazard, that person could fall out, not citable. As soon as we said, yeah, there's a hazard under 5A, although it doesn't say we need to put in another guardrail, 5A again tells us whenever we see a hazard, we need to take care of that hazard, right? We need to furnish a workplace free from recognized hazards. That's a recognized hazard. So just put that other rail up and we'll be good to go there. Straddling the top of the ladder, right? No good. Plus, he's right at a window opening. He's on top of the ladder, which is already going to pitch it one way or the other. If he leans too far, it's going to pitch him straight out the window. No good there. What about these rails? Again, all it has to do is hold 200 pounds downward or outward force. A lot of people go, well, those guardrails aren't flipped up right. No, but they're built to be inside these window and wall openings on this panelized home. So when you set the wall, the guardrails are already there. Well, when I put the drywall in, because it's flush inside that hole, I don't have to take the guardrails out until I put the windows in or the doors in. So it prevents the need to remove those guardrails so often, and it allows the workers on the inside and outside to do their job until they're ready to put the units in the holes. So not a bad idea there either. You're driving by, you take a look at those top holes right there. Does that tell you, hey, they might need some guardrails? Because if so, you just invited, compliance officers onto your job site. When they get there, it looks like a fall hazard. They walk inside, and if you look right here, you can see this is a brace that goes from the top to the bottom. So that's a balloon frame wall that they set the 2 floors up at one time, and then they braced it. But they can't see that from the road. So when they walk in, okay, that's in compliance because there's nobody there. But whoops, here's the air compressor, and it's missing the guard on it. And over here, there's the the extension cord, and here's some scrap lumber with nails. You've invited them to your project by not putting the rails in. So just put the rails in, right? Make it look 100% apple pie order from the outside. Again, we have the windowsill height. It's less than 39 inches. Remember, 42, 21, plus or minus 3 inches. That's as close as you get to close enough. 38 inches is not close enough. 39 or above, so we put the rail up. What's going on here? We got floor holes. You can see debris down on the bottom down here. No place do you see nail holes or anything else from where rails would have been there or covers would have been there. And a lot of times in residential, framers go from house to house to house to house, and they could be 2 houses away and have something like this. Well, they didn't put the rails up. They didn't put the covers on. So under multi-employer worksite citation, they can still be held to a citation here because they created the hazard. Well, then they'll say, oh, well, the rails weren't there. Well, where's your nail holes? All right. They're going to look at that stuff. So if you didn't do it, that's the trouble you run into, right? So get your guardrails up, get your floor hole covers up. Here's one. You can see the outline right here. And you can see by the debris and stuff that it looks like there was a cover in place. It looks like somebody took that cover off, and whoop, we have a bunch of plumbing pipe down here. So OSHA's going to maybe not look at the framer there. They're going to look at who removed the cover that was there. Was the cover proper when it was there? And then who removed it? So under the multi-employer worksite scenario, the framer might be okay because they put a cover on it, they secured it the whole 9 yards, but then somebody removed it. Now they created the hazard. Now everybody in that unit is exposed to the fall hazard and a citation. That's just they've got plenty of lumber there to build a rail or build a cover, and they just didn't do it, right? So that's just, I mean, that's borderline willful at that point. They're just showing that they're not wanting to do the compliance needed there. Doors, and especially in the summertime when it's 90 degrees out or almost 100 degrees, you like to open the door and let the airflow go through. Well, is there a fall hazard on the other side? And if it's 6 foot or more, where are your rails? We need to put rails up there. All right, put temporary rails in place, put whatever you need to in place. You can still get that ventilation you're looking for, but at least you're protected from falling out. If you're going to use stilts, remember, if you use stilts, you got to do it whenever the floors are free from any type of tripping hazards. So cords, pipe, bottles, trash, stuff like that. No immediate changes in elevation, no stairs, no anything else. But now I'm taking that center of gravity and I'm going above 42 inches and I'm raising it the height of the stilts. So then the guardrail systems that we use, we need to start bumping up 21, 42, 63. Hopefully that gets above it. If not, then we need to bump it up again. But that's another system that you can look at there. They've went up 3 rails to take care of the stilts. Guardrails, again, we've got a ladder up there. We've got materials up there. Get your rails up there. You'll get cited for that. Front porches, we're waiting for those new vinyl rails to come in or the decorative ironwork to come in or whatever. We're over 6 foot. We need to block access to this area or we need to put guardrails up. It's as simple as that. How many people use safety nets? Usually not a lot, but with safety nets, there's a whole section in fall protection talking about safety nets. Take a look at it. When used, it needs to extend 8 feet beyond the edge of work. All right. No more than 20 feet below. Needs to be drop tested on the job site after initial installation and at 6-month intervals if it's left in place. Drop test is a 400-pound bag of sand that's 28 by 32 dropped into the net by the highest working surface. So, in residential using a net, that's going to be putting a lot of stress on those walls. Is it going to hold? Has it been tested? Right? We see it in commercial. They'll throw it over interior openings like the steel erectors and stuff. We'll throw them over. Were they ever drop tested? Usually not, because they're over top of angle iron. If they do get drop tested, those angle iron will snap off and take that bag all the way down. So you've got to go through this stuff if you're going to use it. We get to PFAS, or fall protection equipment. We have three basic parts. We have the anchor point, we have the body harness, and we need a connection device. So we need one of each. Anchor point on this one, you can see they're using a truss system, truss bar, going to a rope, and that goes right up to the rope grab and the lanyard hooked to his D-ring. So there's your different parts there. The other gentleman doesn't have anything on. He's just dragging the air nailer behind him there, and that's not going to bode well for him if he falls. So if you get the regular compliance in a bucket kit, you've got an anchor point, lifeline, rope grab, and rope. You'll have an anchor point. The one they're showing is this one that's a non-reusable anchor point. It's supposed to be just snapped off at the end, and you get another anchor point. Then a rope grab, but we have other anchor points we can do. We're going to do this work a lot. I actually put these on my roof. This is a permanent anchor point system. This goes underneath the ridge vent or underneath the, they have one for the tiles. If you're doing the tile roof, they also have one of these for shingles. So you can go on the side of steep angle roofs and stuff like that. But these are dotted across the ridge vent in my home. Just because I've got that permanent anchor point. If I ever need to go up on my roof, I've got a tie off point that's been established. I can go up and tie to it and work off of it. You can also, if you want to take it with you, step up to anchor points more like this. That's a reusable anchor point. It can be used flat or it can be used on a pitch. I just have to follow the manufacturer's requirements that are on there. It tells me what the attachment points need to be, tells me what it's rated for, the whole 9 yards, what I'm supposed to hit. So anchor points are important. Competent people need to know what anchor points are out there. If you're getting into a situation where you don't know what to do, let's say it's a standing seam metal roof and you're getting on it, you can just Google standing seam metal roof anchor points, and you're going to find fall protection anchor points that just run up and down the standing seam, and it's fine as long as you're working. If it grabs, it'll grab in and it'll peel that roof back to shock the fall, to dampen the fall, so you don't go all the way down. Concrete, right? I'm out on concrete patios or something like that. I can drill a hole, put this anchor point in it. I'm done. I release. I take that anchor point elsewhere and I patch the concrete. So there's tons of different anchor points out there. When you get into fall protection, if you don't know, Google it or call a manufacturer or something. They'll try to sell you 50 different ways to do what you're trying to do, but most of the time it's there. Rope grabs, like in this system, basic rope grab has a very important 2-letter instruction, up with an arrow. Make sure that's pointing up. I mean, I know that's common sense, but not everybody uses that common sense button. So sometimes I'll go out there and they'll be dragging it down behind them and it'll be pointing down. Well, if you fall, it's not going to engage. If it doesn't engage, you're hitting the ground, right? So make sure that's pointing up. Make sure the unit itself works properly. This one has a broken spring, so that's why it's gone. And if we look at the teeth in it, the teeth are quite smooth. It doesn't have the grab that it once did. So that's why this was taken out of service, but it has 2 means to lock. So I put it in, flip it up, and run it home. And now that gate can't open anymore. So just important that we know if we're going to use rope grabs, how to use them, how to maintain them, etc. Go to your manufacturer and get that data. And then we'll get to harnesses here in a second. If you don't like the ropes behind you and the rope grabs, you can go to self-retracting lifelines like you see on the right. That's like a yo-yo. All right. So it works like a seat belt. I have it. I work away. I can come back. No big deal. It keeps all that slack away. But if I fall, it grabs me almost instantly, right? It doesn't allow that 6 foot of free fall and then start to load the anchor point. It grabs right away. So a lot of times that might be a better solution for especially like residential, because again, residential, it's very hard for us to find 18.5 feet of free fall. So a 6 foot shock absorber may not work well for that. So making sure we know this equipment. All this stuff needs to be tested every time we use it, and then monthly by a competent person other than the user. Why do they want you to mix it up and get somebody other than the user? It's just a fresh set of eyes, right? We look at the same thing day after day after day. Somebody with fresh eyes comes in and just points out something obvious that we should have caught, but we've seen it every day, so we kind of go, blind to it a little bit. So make sure we have the proper tool for the proper job. Review the manufacturer's instruction, proper use, inspection, donning, limitations, accessories, etc. Inspect personal fall arrest prior to each use. It's very important that we look these harnesses and stuff over, and I'll do that in just a second. Don't use PFAS if it's been damaged, worn, or has experienced a fall. Just like all safety gear, it's one-time use, right? If you fall and you hit your head, but you had your hard hat on, you don't wear that hard hat again. Right? If you put it up on the shelf, it did its job. It protected you. Get a new one. You have a nail bounce back, come back and hit you in the safety glasses, and it protected you. Get a new pair of safety glasses. It's that simple. I had one client that would go, well, you know how many things of fall protection if we took it out of service every time somebody fell? Well, how many people are falling? Maybe we have a problem with that, right? We need to back that up a little bit and figure out why they're falling. But we need to make sure this is one use type situation. I can wear it again and again and again, but it's when it engages me and saves me from that fall that I need to take it out of service. D-rings and snap hooks must be able to withstand 3,600 pounds without failure. So let me see. So snap hooks have to have a double locking means, which means I can't open the gate, right? Unless I hit this release to open the gate. Same thing with carabiners. Again, this is a carabiner that's actually for fall protection. It's not that little carabiner you see at the Lowe's checkout line or the Walmart checkout line. When I let it go, it twists itself shut. So it slams shut, and then this green part twists. So if I take a look at that, right, I can't open the gate until I twist that and get it straight, and then I can open it again. I let it go, it slams shut. That's what you need in fall protection. That way, when it hits against the side of that gate, it doesn't allow you to bail out. Inspecting the harnesses. Let me grab a harness real quick. Now I have some newer harnesses here. This is a really good one. It's from Super Anchor. They're super comfortable and stuff like that. But we're going to talk about the design with these back patches and stuff like that here in a minute. And then I also have this Miller one as well. Again, this is a little older, but it has the built-in backs. This is going to, these type of harnesses don't drag down as much. You'll see in the pictures, a lot of these, the D-rings will be down because they're pretty much the lowest end harnesses you can get. Something with these built-in features, keep the D-ring up where it's supposed to be, keep them a little safer. When I go to inspect a harness, the first thing I do is kind of pull this D-ring out a little bit and look at the webbing behind it. I also look to see if it's rusted, right? And then I check all the stitching. I check all the leg straps, all the hardware, and I make sure it's all free to use. My adjustments are free to use. Find any of the adjustment points and inspect your adjustment points, especially with something like this that has like the flat grabber right there, because that can wear on the material itself. So I'll kind of play with that a little bit and take it in and out and take a look and see if that's solid or not. And then only once all that stuff's done and I inspect it, do I put it on. And I'll just go ahead and do that since we're working on this part. So to properly put the harness on, I'm going to first get my harness adjusted and straightened out so there's no twists or turns, because I don't want any twists in the nylon. Put it on like a jacket. And I want my D-ring to be up there between my shoulder blades, right? Then I'm going to find the sub-pelvic strap, the butt strap, right? And I'm going to tuck that underneath so I can get my leg straps nice and flat. And again, no twists, no turns. and put those on. Then tuck this away. Very important to tuck these leg straps away. If it's like this, right, and I just happen to grab that, I'm right back out of the strap, okay? So it's important that when I do use these tongue buckles, I put the strap away. Same thing on the other side, make sure there's no twists. And then again, tuck that away. And then the last thing, which is usually where people start, I want to do is put on my chest strap. Now this has already been adjusted to me. I can feel comfortable in it. It's pretty tight. So I'm going to check and make sure my chest strap is directly across my chest. If I'm female or I have chest tissue, I want to make sure it's above the curve because anything that's caught here will get torn, right? I don't want to put this all the way down around my belly. I can fall out of it. If I don't, it gets hooked here. It can push all my innards basically up into my lungs and I won't be able to breathe. And then I can adjust my height straps. Subpelvic strap is underneath the butt. If I do a little bit of a squat, I can feel that. D-ring is between the shoulder blades. And if somebody were here to check me, they pull on these shoulder straps and see if I can fall out, which I can't. I'm put away correctly, okay? Now, we talked in the one before about tying back to myself. So if I have that lanyard tied to my back and I come up here and clip it to myself, we have that situation that we saw with the rebar. This gets hooked, it yanks me whichever way it's going to go. What I should do is find my little tearaway tabs, like this right here, that with not too much pressure, this will break away. If I don't have those for some reason, I can also just tuck it like this. Everybody see that? And then if it rips away, again, it just kicks that out of the way. It doesn't put me underneath the machine, all right? Questions about proper fit of the harness itself? Anybody? Leg strap should be tight enough I can take my hand, go through, make a fist, and not come back out very easily. You do not want to see this for harness fit. Sorry, taking a second. You don't want to see this person walking around. Let me see if I can get this down a little bit. All right. Those loose leg straps, right? Because if I fall, it just grabbed me right here on the thigh. And when it goes up, again, I've got that femoral artery right underneath there that if it grabs and it tears, I can puncture it 5 minutes, bleed out. So make sure they're fit in their harnesses correctly. Anybody grab any harnesses that want to check fit? Now's a good time to put them on and we can look at them on your camera and talk about it. We'll also see some pictures here. Any questions so far?
So far,
I
I was
do-
going to say the questions are up. Oh, nope. Who's that?
No, go ahead.
Oh, go ahead. I was waiting for a question.
Okay, so you might have covered this before. I have a question about like we had a situation where the GC wasn't providing say an entry exit point into a 40-inch data room. I have a picture here that I'll put up. But my ultimate question is, if the GC is not providing, they won't let you build your own walkways, ladders, things like that on a commercial job site. Just curious how, where does the blame take place? Now, I know that we're responsible because you shouldn't enter or exit a workplace or a work area without the proper entry exit point.
Sure.
If the GC is not providing it, is it possible if they're cited for OSHA to take away your citation ultimately if the GC is not providing it? Any of that makes sense?
Okay, so it's kind of a two-part question here. One is, what do we do if we don't have a proper entry-exit point? And the first thing I can tell you there is it's up to you to make it safe. So at the end of the day, any of this stuff, that's why they came up with the multi-employer worksite citation rule. OSHA came up with that. Anybody who creates the hazard, exposed to the hazard, is the shoot, what's the word? Is the company that's actually hired or contracted to take care of the hazard. So if you have a contract saying you're going to take care of all the guardrails, et cetera, all those people and the controlling, which is the GC, can all be cited for the same issue. So proper access point, first thing is if I don't have a proper way, and we run into this in residential all the time with people who want to work up in the attic space, they'll go, well, you don't give us an anchor point. Well, that's not for the builder to provide you the anchor point. You are putting yourself in that situation. Can you come up with a safe way of doing it? Can you do a work deck? Can you, whatever it is, you need to come up with that solution to get in there, or refuse to do the work until you get that safe means of exit and entry. They have a schedule too. They've got to work with you a little bit, but it will not relieve either of you of a OSHA citation, right? So you got the GC who's willfully not doing it. So maybe they get a little more severe. You don't know. But at the end of the day, you're still paying a citation probably, and it's going to be on your record. So under multi-employer worksite citation, you can't just say such and such was the one doing it. We see this all the time with both residential and commercial with cutoff saws, right? You've got a big, huge plume of dust because they're cutting concrete, and the person cutting has ear protection in, has their respirator on. But now you have employees walking through that area that are exposed to that high level of silica. They could be cited, right? Because now they're exposed. So yeah, it's not really going to relieve either of you of a citation. But if you're going to do the work, you bought it. That's what it is. End of the day, you plug into a generator with a bad outlet, you bought it because you plugged into it. You're using it. So that's where that comes in.
All right, thanks. Appreciate it.
Yeah, not a problem. Any other questions? All right, we'll keep going. If you get one, just ask. Another thing on these harnesses and stuff, they usually have inspection tags. Those inspection tags are supposed to be filled out, but most people will just take the, see if you can see that. Yep, there's an inspection tag. Notice it's about 5 years and it's got 12 boxes, so you can actually check it every month. That's just the little yo-yo I have here, but all this stuff has those tags. If you don't, you can take the serial number and make your own. There's nothing against, taking the serial number and making your own. Just make sure you inspect it once a month. I usually say make the first Monday of every month inspection day. You got to do your first kit. You've got to do your fire extinguishers. You got to do your harnesses and stuff. So have your competent person walk around first Monday of every month on the job site and start doing these inspections. There's that D-ring wear that I was talking about. And again, I just showed you the Miller that I had. This is the one from Super Anchor. You can see like the strap is built in to the protection all the way around. There is no slide on the top half of this harness. And the whole reason is to keep this D-ring right where it's supposed to be. So yes, a harness like this might be pretty cheap, but what's it really going to do for you, right? We have the subpelvic strap that you can see here. He's got that. He's got his D-ring way too low. Here's where the shoulders make the triangle. That's where the D-ring needs to be. So we can see that's probably 6 or 8 inches low right there. If I grab this shoulder strap, I guarantee you that I could just pull this harness straight over his shoulders. If he falls head forward, you got a little bit of muscle here that makes a little bit of an angle. You can shoot out of that harness, okay? So getting the proper one with the proper straps, that's going to be a big part of the game to keep everybody safe. This isn't going to allow the D-ring down. That type does. They slide. So that other one that I showed you here from Miller, same thing. It's got it built in. This one can slide, but it takes a lot to slide it, right? So I've got to loosen it up here and then move this webbing back and forth. So when it comes to being the competent person and figuring out which harnesses and stuff to get, you really need to look at a little bit better harness that might have a system like this, especially if you're going to be tying off back to ground level and not above you all the time. So those D-rings don't slide as much. Chest strap, again, make sure it's not too high so it's going to come up and bust you in the chops. Make sure it's not too low so you're going to fall out. anchor point, make sure it's put in per the manufacturer standard. Again, OSHA's talking about 5,000 pounds. Anytime you put in an anchor point, 5,000 pounds or twice the intended load. Let's do that for a second. 5,000 pounds. Can a pipe hold 5,000 pounds? Can, a parapet edge hold 5,000 pounds? Can a door frame hold 5,000 pounds? There's a whole lot of what ifs that go behind that. So the competent person needs to know this stuff. My basic rule of thumb is, can you hang a regular half-ton pickup truck from it? Because an F-150, Chevy 1500, any of those things are between 46 and 5,600 pounds. So if I can't hang it from it, that shouldn't be an anchor point. Okay. Second half of that's twice the intended load. And that's how they came up. OSHA came up with the 5,000 pound. They took a worker with tools and everything else. And they said, if we even call them 250 pounds, they fall 6 feet. They're going to hit with an impact force of 2,500 pounds. Remember that 10 times your body weight at 6 feet. Multiply that by 2, that's where you get 5,000 pounds. So it's not just your weight times 2. They need that maximum arresting force. So then we go over to our connection devices. Our little yo-yo friend here, right? We're going to take a look at that. And it's telling me that this is good from up to a 310-pound person. And it's going to reduce it to, where does it say? 900 pounds. So if I look at this part, and I don't know how well you can read it, there's a maximum arresting force of 900 pounds on a 310-pound worker. So now I know my maximum arresting force is 900 pounds. So what's my minimum anchor point being a competent person? 1,800 pounds, right? We did 2 times the maximum intended load. So that's part of the competent person's job when it comes to fall protection, is knowing this stuff. Sorry, it's a little loud when I move that stuff. Shock absorber, right? 6-foot shock absorbing lanyard, right? We got the whole deal here. This also tells me maximum arresting force is 900 pounds. Now I can have some of these lanyards that say maximum arresting force 1,400 pounds. I usually don't have them less than 900. So I really need to know what my connection device is and make sure I put it in properly so I know what my anchor point is. Commercial, we can find 5,000 pound anchor points quite a bit. We have concrete and steel and stuff like that. Residential, where we're building with 2x4s and plywood, it's very hard to find what I can hang a truck from, right? So I need to find what's going to hit me at 5,000 pounds or twice the intended load. The way this works, okay, we saw the retractable, that when it hits, it grabs you, right? You can go in and out, but when you drop, it grabs you. This will not allow more than a couple feet to stretch if you go to maximum impact on this. The other one, you have to fall that 6 feet, right? And when you fall that 6 feet, what happened there? We had the impact come out, the straps, and we have the strap that decelerates you. That's this part, where it's actually taking one strap. Everybody see that's one strap? And it's ripping it in 2. That's the deceleration device. And then it has a catch strap here. Should you rip all the way through that, this catch strap will grab you. That's what slows that 2,500 pounds of force, which would be at 6 foot, down to 900 pounds. Okay. So that's just kind of how that works. And yes, that's already pre-done. I can have 3 people play tug of war on both sides and you're not ripping a stitch. You have to get that impact to open it up. Okay. All right. Anchor points. This one's on a roof truss, right? You see the roof truss anchor point right here. You can take a bunch of them. They're from Super Anchor has one, and some other ones have these truss anchor points that you have to set your first, say, 3 or 4 trusses up before you can actually tie to them. And they tell you, how they need to be braced, etc. Again, you got to follow the manufacturer's standards here. Look at that truss. That thing is bent all to heck right there. Just a observation. Now he's tied here. He's not working in his safe zone from that anchor point, right? He's working way off to one side. So now we have to worry about swing fall hazard, right? And we'll get into that in a second. Here we have one of those big yo-yos tied back to the ground on an anchor point like this. But now we're taking that wire rope and we're running it right around the edge of a 2x4 there. That's a bit of a problem. Let me see if I can change that to maybe red. So now we have a point right there where that wire rope's going to run right across the edge. And if it runs across that edge, what's going to happen is you're going to get some wear and tear, and it's going to cut that even wire rope and let you fall. So we got to be careful of that. This is more on the West Coast. They use some of these Skywalker systems. I don't see it too much on the East Coast here, but it's a mass beam that gets put into the ground in concrete, comes up, and then you put your wire ropes above it. See this in commercial quite a bit, but don't see it in residential here as much. So this is basically a Skywalker system. These wire ropes should be about 7 feet up. So you tie off above you, and you have one wire rope on both. You see right here and here, those are shock dampeners. So anytime wire rope is used in fall protection, you have to have a shock dampener, because with wire rope, it will actually increase the impact when you hit wire rope, because wire rope goes down. Think of like a guitar string twanging, right? It's that boing, right? That vibration will amplify to the anchor point. So without a shock dampener being in place in a wire rope system, you're asking for trouble. You're putting a lot more shock on, or a lot more vibration and a lot more impact on the anchor point itself without a dampener. So that's why you always see, if it's wire rope rated for fall protection, there'll be a dampener built in. Different anchor points. Again, we have the SRL right here. We have the disposable, which I showed you earlier. That's a one use, and it tells you right here, one use. This tells you 16 penny nails, 3 inches in length, and it's giving you the anchor point that you need. Here's another system over here. You can't allow a worker to free fall for more than 6 feet. This is really a problem when we go to rope systems. We put the lifeline out, and we've got the rope, and they attach it to the anchor point, and then they pull that rope grab all the way down to the edge of the roof where they're going to be working, and then they start working up the roof, and they forget to pull through their slack, and that allows that when they fall, they're going to slide all the way down, hit, hope that anchor point still holds, because remember, we're putting a lot of load on the end of that, and then it's going to engage whatever the connection device is. So that's usually when we really deal with like the free fall more than 6 feet rule. It's usually when we use these ropes. Another thing about ropes, we don't want to see knots. Whenever we put knots in it, we decrease that rope strength 85 to 95%, depending on the knot. The best knot in the world, I think, is 55%, right? If anybody fishes and they tie on their lure, where does the lure break? Right at the knot, because that's where you decreased its strength. They do make knot eliminators, all right? Simple device that we weave the rope back and forth. The last one, we take the tail, put it back in here. Now we have a good, solid rope system that now I can put a fall protection rated carabiner on and have just as much strength as a manufactured rope end right there. So this one's called a Hold Me Termination Anchor. All right. Oh, doesn't tell me. B Access Products. Miller makes them. Guardian makes them. Super Anchor makes them. So any of those can make that system right there. Little disposable anchor point for you in residential. Safety strap. This goes on like the top plate or wherever you're going to nail it in. You nail it, then it tells you to wrap it, and it's got stitched diamonds there that you're supposed to nail into. You wrap it, and now it's sitting out in front of the house if you're a siding contractor, or you can put it up through the roof. Wherever you want to use it, you're good. When you're done, you just cut it off and throw it away. It's cheap. All right. So another anchor point. Here's your calculating fall distance. That's where we get to the 18.5 feet with a 6-foot shock absorbing lanyard. Swing fall. Again, we never want to work 30 degrees or more away from our anchor point. So the higher our anchor point is, the more area it gives us to work, right? Because we can still stay in that, think of that funnel, that 30-degree funnel. We can't, however, just walk all the way over to the other side of the roof. When we do, that creates this swing fall. 30 degrees, that's the way the anchor points are always tested to hold your load, not side loading that anchor point. If I were to fall this way, now I've side loaded that anchor point and I might tear that anchor point directly out. As long as I fall inside of this zone, it's going to catch me. It's designed to catch me. This guy's way out here, right? He's out on this roof. He has an SRL, really nice system, but if he falls, where's he going to end up right now?
Swinging in that building.
You got it. You got it. Anybody remembers George of the Jungle, right? Watch out for that tree, right? Same thing's going to happen to him. He falls off. He's going across the edge. And when that edge hits that wire rope, will it cut it? And if it cuts it, he's going to hit the side of the building. Then he's going to fall to the ground. So again, we need to manage that slack. What would we do there? We'd move that anchor point to the center of this roof and work off our SRL, and we wouldn't have that slack. Look at this poor guy, right? Tell me your hard hat falls off every time you look down. You need a lesson from this guy how to put your hard hat on. I mean, his butt's higher than his head, so his hard hat's really really holding on, but he's got his toes, his legs, and everything else planted against that roof trying to do that job. Can we change his work position to make this safer?
Absolutely.
Yeah, we could put him on a ladder, right? He
Yep.
could do that job from a ladder. He wouldn't need to be tied off, and he wouldn't be scared like he is right there. That's pretty rough stuff right there, right? So again, maybe we don't need fall protection. We just need to change his work position and put him on a ladder. This guy, my roofers, I always get the complaint, well, we already have the hoses, and then we're going to add a rope to it. And now I have two things around my feet. Well, A, you learned how to deal with the hose around your feet before from the nailer, and that's fine. You'll work with that. B, the rope will actually grab you and keep you from hitting the ground. The hose on the nailer is going to cause you to slip and cause you to fall to the ground. Now, I was just out at the International Builder Show last year talking to the guys from Super Anchor, and they have a rope with the hose inside. So you want to put both in one. Now you have your air hose inside of your fall protection rope. So you can talk to those guys maybe and take a look at that product. I'm sure other people make it as well. That's just the first time I saw it. Here we go. Again, we can't use stilts whenever there's debris, which we see this little board right here, or immediate changes in elevation, which again, we have stairs. So we shouldn't even be using stilts, but we have that open-sided hallway right here, just like fatality number 2 that we talked about earlier this morning. Where's the guardrails, right? Got to get the guardrails up. Limitations of conventional fall protection. Again, will that anchor point hold? If we're just putting the floor joist system up, or we're just putting fresh trusses up, and we've only got the first one in, is that going to hold a fall protection system? We've got to take a look at that. What's the limitations there, right? Where's the D-ring? Are we tying off to our D-ring? A lot of times with our roofers, I see them tied off to the side D-rings. Can't do that. That's not an anchor point. That'll snap you sideways, right? You got to be tied off to that back D-ring. All right. Going right along into the next part, we also add in guardrails, right, to this whole deal. We also add in floor covers, which we're going to talk about. Top rail and stair rails, 36 inches in line with the riser. Mid rail, halfway in between. Toe board around our landings, right? And again, it needs to hold 200 pounds. What's that look like? Does that meet that criteria? I don't think so. No. We have no mid rail. Look at all these nails. Got exposed nails. What the heck is this thing? What's that board going to be used for? It's funny, I teach this all over the U.S., and everybody calls that either the plank or the diving board, right? Because what's going to happen? Big guy stands on one end, little guy walks the plank and goes out there and finishes the drywall up there at a higher level. Can't let that happen. So guardrails aren't right, exposed nails, missing mid rails, not holding 200 pounds. There's about 4 or 5 violations just in that picture alone. Again, in compliance on the right, just set them, not in compliance on the left. So when is just setting them an excuse? It's not, right? Leave your ladder going from first level to second level, then we can block it off until we get the rails in. But as soon as we set those steps, we need to start incorporating rails. See, they pulled the ladder up there, they set their stairs, they did nothing to protect the employees going upstairs to downstairs. Violation. Here we have a modular set of stairs that go in. Okay, those square tubes can extend different lengths, etc. Good. That's a good hand and stair rail situation. This one even goes up another 21 inches to take care of our people wearing stilts. So there you go. Hook on the front, again, using the safety boots. There's tons of different guardrail and handrail and stair rail solutions out there. In commercial, they've got the concrete and the steel that actually clamps to the riser to the back of the stair tread, and they can put up rails there too. So there's tons of different ways to take care of that. Hole covers. Anything over 2 inches we need to worry about. Who's going to fall through 2 inches? Well, I'm certainly not going to fall through 2 inches, but a piece of pipe could, a screwdriver can, other stuff can fall. Fall protection doesn't just talk about you falling, it's also about materials falling onto others that it covers in subpart M a little bit. So hole covers is part of that. Anything over 2x2, we need to start worrying about. Again, if we're going to deal with a hole cover, it needs to hold at least 2 times the intended load, secured in place, and clearly marked, indicating that it's a hole or a cover. I can tell you throughout my career, I've heard at least half a dozen and even seen a couple horror stories where people go out, there's a piece of plywood on the ground, they need that piece of plywood for whatever, they go to grab it, throw it on their shoulder, step underneath to catch that load, and there was a hole there, and they go straight down. So that has happened, but if it said hole or cover, at least it gives them a chance. If it's secured in place, they can't pry it up in the first place, so that's why you need those 3 parts to a hole cover. So here we go. We're starting to get into the winter time. We really need to be able to get our drywall mud and stuff like that to set up. So we want our HVAC in. We want to make sure we've got air running through the place. And then we have to put a cover on it. Well, they make these little hole covers, especially for that. It says hole. It has a ton of little holes right here for screws, which each one has to have a screw in order for it to hold 2 times the intended load. And then it keeps a filter so all the trash doesn't go into your HVAC system. So at least you can still get the air in, and you can get the drywall mud to set up and stuff like that. So again, they make that. They make the little round holes that go on the core drills when you go through a slab or through a floor, right? Put them in. Piece of plywood, as long as it's going to hold 2 times the intended load. Good to go. This one, I had a fatality that was similar to this whole setup right here. We had a father and a son team working together. This has probably been about 15 years ago. And the son was on the back and had 2 2x12s on his shoulder, walking just like you see the gentleman over here. And the father went around one way. The son obviously had to move around to get around the corner, didn't pay attention. There was an opening, elevator shaft opening just like this, and he slipped down, and they don't know if he broke his neck when the 2x12s caught him when he fell or when his head hit the concrete, but he was dead instantly. And for what, right? I mean, we put a floor cover on it or a guardrail. That doesn't have to happen. He may have banged against the rail, but he wouldn't have fallen through that. So again, how long does it take to do some of these little compliance things? Long enough to be alive. That's what you need to know, right? Here we have same situation, right? This poor guy backs up a couple steps the wrong way. He falls. No hard hat, no nothing there. At least he has a hard hat on. I guess if he falls, he at least has a chance, right? No good. There's that little hole cover that I just showed you in use. But again, you see all the screws are in like it's supposed to be. You do screws on a couple corners, that thing will break. So make sure you have all the screws in the way the manufacturer tells you to. Here's a simple piece of plywood. It's just marked do not remove. It's a hole cover. Is that compliant? Residential, heck yeah, that'll hold 2 times the intended load, right? But now a couple people asked about commercial. If that's on a commercial site and I've got scissor lifts running around and forklifts running around, what's my intended load? That whole deal changed, didn't it? So maybe I need to put up a guardrail to keep them from running into that hole rather than trying to put the hole cover on. Positioning device. Here we have a rod buster tie and rebar with a positioning device. Big thing about positioning device, it's not fall protection. It's to keep you in a position, right? You can't fall more than 2 feet and your anchor point needs to be 3,000 pounds. We don't use this a ton in residential. See it more in commercial. You see it a lot at Home Depot. That's why they still have the belt or Lowe's or one of those places on those order pickers that go up where the person's tied off and they take the forklift that goes up and gets the product. They can still use those body belts because it's positioning, right? It's not fall protection. Here we go. Same thing. Positioning device needs to be inspected the same before each use. You need to be trained on it. Body belts for positioning only, not for fall arrest systems. Residential exception. So residential still has a little bit of an exception there. It says when employers can demonstrate that it's infeasible or causes a greater hazard to use conventional fall protection, they need to develop a program. That's 1926 502K. You're probably going to have a written program because you're going to have somebody who has to get on the roof first and put the anchor point up. You're probably going to have a written program because you're setting trusses and you're not going to be able to tie off while you set the first truss or two. So the written program we'll talk about, but again, that's a last means method. So it's a last ditch effort to be as safe as possible. Infeasible. Let's get a few of these things out of the way. Infeasibility means it's impossible to perform, right? You just cannot do it. It does not mean you do not want to perform it. It's technologically impossible to use conventional fall protection. Again, I'm the first person up on the roof. What am I going to tie to? There's no invisible sky hook. So I need to go up there and set an anchor point and then set all my other anchor points so I can get people up there safe. That's when I can figure out that, okay, this may be infeasible to actually tie off before I get up there, so I can do it safely. Examples of infeasibility: they don't expect you to rent a crane and raise the whole roof up at once. That was something that they thought about at first when they started doing this. But remember, trusses are meant to hold loads this way, not this way. So if we set all the trusses on the ground, who's the engineer that's going to tell us what bracing to put in so we don't blow the trusses apart when we go to pick them, right? So that's what we needed to look at there. They don't expect a home builder to erect a scaffold all the way around the exterior of the house. They can, but they don't expect you to if that's your best bet. And if hazards created by compliance with those standards are greater than non-compliance. I had an electrician that I always use as my rule of thumb on this one. They had they were changing dock lights out from regular old dock lights to the new fiber optic lights that are, so much more energy efficient, etc. Well, instead of being in a boat doing it, they did it from the ground using an extension boom lift, right? So you're on the dock with the boom lift and you can reach out over the water and do the work you need it to do and then come back and go to the next spot. Well, if you're working over water, you need a personal flotation device. If you're working in a boom lift, you need to have fall protection. Which one wins, right? So if the lift falls into the water, you're only going to get so far from the lift, so you'll drown with your personal flotation device trying to get you to the top. So this is one that the hazard we felt was created by compliance was much more than what we could do with just using the personal flotation device alone. Because if we fell in, at least then the body had a chance to get up out of the water versus being stuck to the lift. So that's one of those examples, and we'll go through some more later in the presentation. Establishing greater hazard. So OSHA acknowledges that the employer's ability to pre-plan for fall protection, there may be cases where installation isn't an effective deal, then you're going to have to come up with a written program. All right. That OSHA takes the stance that they feel employers should be able to be in compliance. It's up to you to prove it otherwise. That's kind of the way that it all sets out. All right. It's OSHA's presumption that conventional fall protection is feasible and will not create greater hazard. So it's the employer's burden, and I'll highlight that. This is the way it's actually written. The employer's burden to establish that that it is appropriate to implement a fall protection plan with an alternative means. So we'll talk about that. Any site-specific plan, the qualified person develops it, the competent person carries it out. So you may have even seen that on your pre-test. What does you're getting ready to write a program. Does the competent person do it or the qualified? Qualified writes the program, competent person carries it out. Needs to be job site specific, needs to have the name of the competent person, needs to have the name of the people who are going to be, say you're using a controlled access zone, who's allowed in, who's out. If you're using a monitor, which is an alternative means, who's the monitor? Put their name down there, right? What's their training, etc. This is a last resort only, okay? This is not something we do just because we feel like using this. This is a last resort only. Again, 502K, the employer has that burden. The fall protection plan needs to document why use of conventional fall protection systems are infeasible or what the greater hazard is. If I'm getting ready to deck a floor, okay, and I've got all my floor joists set across there, can I tie off? Can I physically tie off to a floor joist? Sure I can. Is that going to hold 5,000 pounds? Well, there's the tricky part. If I sideload that joist, am I going to rip the whole flooring system in? Maybe. So then I might have to come up with a different way to do the decking on the floor. So maybe I need to use a leading edge type program. Must be written, site specific, and available on the job site. Current and up to date. If your competent person change the name in the program. If your people that are working there change the names in the program. Needs to be site specific. If we're using a controlled access zone, where are the boundaries? Who's going to police those boundaries, right? How many times have you seen controlled access zone signs up and nobody's there anymore? It was great when they put them up for the amount of time, but then they just left them there. It's kind of like caution tape. You ever walked by caution tape and stepped over it? Went, yeah, caution tape. Didn't even look up, didn't even look around. It's just overused. That's the problem with controlled access zone signs. We need to make sure somebody's policing that and keeping people out of that controlled access zone. Must be in plain view, clearly visible, and restricted to authorized personnel only. All right. Let's look at this. So, can we all agree that the gentleman in the blue hard hat with the arrow pointing to him is exposed to a fall hazard over 6 feet? Can we pretty much agree with that?
Yes.
Okay, good. The gentleman on the inside, they're standing on a 6-foot rolling scaffold. So they are not exposed to an 8-foot fall hazard. They're just under 6, but they're on a scaffold, which allows 10. So they're quote unquote in compliance. Why is the gentleman outside not on a scaffold inside? Most likely this is a 3-person crew and he also operates the forklift. So it's more out of convenience than it is what is actually there. So now we need to take a look at this. If he needs to be there, can we put a guardrail up? Well, sure we can, but it's going to block everything we do. And we're going to be diving between the rails and all that sort of thing. So guardrail is really not the means of protection that we can use here. Can we tie off to one of those floor joists? We physically can, but we're going to hit the ground and probably knock down the other 2 guys if we do fall. So that's not going to work out. So what can we do to make it as safe as possible? I can tell you that hose under his feet and the rocks behind him and stuff like that is not making it as safe as possible. But that's up to us. If we're the competent person, we feel that strongly about it. Now we have to make that argument just like we just talked it out. We got to make that argument in our written plan. We don't send the plan to OSHA. OSHA, honestly, the most often time they see it is unfortunately after an accident and they ask to look at it. They go, well, what could you have done differently to show that your program wasn't there? It's not for them to say yes or no about. They're not going to approve a safety program at all. So you really have to be convincing. And I tell everybody, be as convincing as if somebody already died. Is your program going to be convincing enough to convince that jury? That's where it comes back to you. So if you really need to do it, put that as kind of the measuring stick that you're going to go by there. This gentleman, again, we have the basement. Now we're starting to put that decking on. It's about at his hip, so it's probably about 38, 39 inches there. Is he really exposed to a 6-foot fall hazard? Probably not yet, right? But when he gets up on that deck, because he can only do so many pieces of plywood from the ground, when he gets up on that piece of plywood, now we're going to have issues. So we're going to have to walk through that. I usually call this picture first day of compliance, because if you work like this, you're not going to work very long. We have everybody tied off in every which way, and it's pretty much a spaghetti string mess. You usually learn after the first day or two, and I see this with roofing clients and stuff that really start tying off a lot. They'll start working zones of the roof. So again, you've got that 30-degree zone. So the person on the left would be working all the way on the left. The person that's tied off behind, that if he falls, he's knocking the other two guys down, he's not going to cross lines like that. It takes a little while to learn that stuff. And if you look, again, D-ring's too low, D-ring's too low, exposed to this fall hazard, tied off on the other side of the fall hazard, so he's probably going to hit the ground before it catches. Harness way too loose. Look at that. And will this floor system hold 1, 2, 3, 4 different people right now? So that's 20,000 pounds, right? Or twice the intended load. So again, from the road, it looks like they're compliant. You get a little closer, compliance is not happening with them. So this is a crew that does the controlled decking zone, and what they do, and we kind of drew it in here, but I'll show it to you in real life here in a few minutes. They put the first few pieces up, and then they put the guardrail all the way behind them, and then start running the guardrails down the side of the floor. And they go to no more than 2 people. The people are trained on the program, and part of the program is look before you walk. Like, you can never take a step back. You look, and then you walk toward where you're looking. Make sure you don't fall in the hole. And then we keep the guardrail going, and we're only going to expose 2 people. We're not going to put 10 people up there. And their whole job is to get this deck down. So this is called a controlled decking zone. This used to be the fall protection that we could do in residential. All right, we paint our line 6 foot from the edge. Some people still do this, and that way they don't put debris within 6 feet of the edge. But this used to be a option. The floor's already been completely decked here. So where's your argument that you can't tie off? You've got a completely decked floor system. You know, I got attachment points. I can tie you off there. So it's going to be really hard for you to use this line anymore and make it compliant. Panelized home. Again, they've got a mess around them. So what do we do to make this a little safer? Because they're going to step right over top of this mess to get out here and get that wall panel up. Maybe we need to be a little bit better about our housekeeping there. Do they need to be tied off? Do they have a 6-foot fall hazard? It doesn't look like they're very high right here. It looks like maybe they're a couple feet off the ground, so they probably don't even have a fall hazard there yet. This is that decking crew. Once they've got the first couple on, they put those guardrails up, and you can see that's well beyond where the decking is. The decking is probably about here or so, but they just run it all the way across. And they really like this because even if they're setting framed walls, when they stand them, they can actually kick them up against here, and you know their guardrails are already in place until they put the guardrails on the interior holes, and then they can take the guardrails off from the outside. So this crew, it took them a couple houses to kind of get used to this. Now they think they're faster and better using it this way. So maybe that's a solution for you to consider. This is using that top plate scaffold system. Again, I've still got a person in the truss. So are we 100% in compliance here? Well, do we have a written program? Why does that person have to get in the truss? Because they have to untie the crane, right? So they have to untie the crane. They put a couple cross braces in. They come back and they crawl back down into the scaffold there. If the scaffold collapses, your options really are hold on and see where you go, or try to jump. And if you don't have a platform on the outside of the house, what are you going to jump to, right? So again, it gives you a little bit more compliance, but again, we're going over 18 inches without a ladder to get up on the wall. There's a few problems here. Maybe if you could get a scaffold underneath so you could reduce the fall hazard, that would be great. You're not going to be able to get a ladder in these tight trusses the way it's sitting. When I was out at that International Builder Show, I was introduced to this product for trusses, and this is a pretty cool little toy that came out. The gentleman was a framer, I think 30 years or so. This is called Truss Locks, TRUSSLOX. But this just goes on the truss. You don't have to screw it in. He did include a hole there in case you did want to screw it in, but it goes into the truss while it's on the ground. And then when you fly and roll that truss up, it uses this to lock in. And then it just locks the whole truss in. So now I don't have to put that person out there to put those intermediate braces in. I can set an entire house truss system with these truss locks, one on both sides of the truss, and it's going to lock that house in. He just really, he knew there was a better way than putting people at risk all the time. And then he also came with a device that looks a lot like this part, that's a truss clamp that they can use when they fly the trusses, and there's a rope. He's got a little hole here. The rope goes through the hole, and then he can pull and dislodge that truss, so you don't have to put somebody up in the webs anymore. So again, if you want to check it out, it's just a neat little thing that I saw. I think it was one of their inventions of the year for IBS a year or two ago. But he has some things on YouTube and stuff like that you can check out. But that might also be a better solution for this scenario. Again, we got to get the person up there to put those in. That truss lock system would eliminate this person's position being up there. So, we could get underneath with scaffold, or we could get underneath with a ladder or something like that and start installing our bracing from the bottom up. Once we've got so many in place, again, we can go to Super Anchor or Guardian or one of those people and get one of those truss bars and go over top of the trusses. A lot of those truss bars now go over 3 trusses to distribute that load, and then they can tie off and get up in the webs all they want. So again, the guys working on the ladder, completely compliant. The guys up above that, could I get a scaffold under there? Yeah, maybe. Could I get a ladder under there? We'll have to see. But, I want to see their written program and why they're doing that when this happens. They've got those truss bars that I was just talking about that goes over the 3 trusses. He's actually standing on one there, and he's tied off. He is too. That's quote unquote legal. Shouldn't be on the top plate. Should be on a scaffold or a ladder. But where they're at, they are tied off, and it should, as long as they've got the right connection device, save them from falling. Slide guards. So we used to be able to do low sloped roofs with slide guards. If the roofing system's not going to support an anchor point, maybe the way it is, you can't get, but until it's 3/4 or all the way sheeted that it will hold a load, then maybe slide guards might be a last option. But again, you're going to have to write that out and explain that in the program. This gentleman working up into the attic space, we talked about that. How is he going to tie off, etc. If he had a work platform and guardrails, he's fine. If he's working off the ladder, he's fine. And when we put that out there, he's like, yeah, I can work off the ladder. Then do that. Then you don't have to get out on that platform and you're not in a fall hazard. First person up, again, maybe I have to have a written program just for this. First person up, go in, install that anchor point, tie off to that anchor point, and then install the rest of the anchor points. So, there's no invisible sky hook here that I can protect that person. So maybe that does require a written program. My interior trades. Just because you're doing finishes, are those people up top still exposed to a fall hazard? Certainly they are. So is it 6 foot or more? Certainly it is. So maybe I use a door opening bracket. So there's ones that go in window and door openings that just go out and provides me an anchor point, and I can tie them off up there. Or they can work off of a ladder or a scaffold from below. Deck builders, sort of the same way. Maybe I use that strap that I showed you earlier to come out of the top soffit area. I could have those straps right up in here, and that would give me an anchor point that I could tie these guys off to. They do have window openings. They could open that up and put a window bracket in. They have doors here. They could do a door bracket here. So many things they could do to tie off. Saying I can't tie off there is going to be very difficult to prove. And we get into rescue. Any questions so far? Okay. So if I'm going to put you in a hazard, I have to figure out how to get you out of that hazard, right? As an employer. So if I put you in a confined space, I have to come up with a confined space rescue. If I put you at height, I have to come up with a rescue at height. So understand that you got to train on this. Just like you have to train on first aid CPR, you have to train on pretty much anything else. Your fall rescue plan, you really need to train on as well. The whole goal is to make sure somebody can be safely rescued within 3 to 4 minutes. So person falls within 3 to 4 minutes, we react, we go through our planning procedures, and we get them rescued, get them on a platform, whatever. We get proper EMS on the way if needed, get ladders, get whatever to them that we need to do. There are some other samples that I can show you. I got to see if I have that harness with me, but we can look at that as well. Most rescues fail because it's not thought out. We think about how to put them in a harness and how to tie them off, but we don't think about how to get them down. So you need to do that. You need to educate, and you need to run through the drill a few times. I'm not saying hang somebody from a balcony and go rescue them, but maybe hang a bag from a balcony and figure out how to get it down. Maybe, go through any of those types of scenarios and figure out what kind of equipment you want to keep on your job site when you're in a fall hazard area. How many of us have ever worked at height and been the only one on the job site before? Kind of a scary thought, because if we fall, who's going to rescue us? Who's going to provide any protection? If you're working on that boom lift that I showed you where the guy fell out of, same thing. Who's rescuing him, right? Are your employees trained in basic first aid? If they're rescuing, they should be. You got to get the first aid CPR training. Are there adequate supplies available? Where's the closest hospital, right? We need to train on all that stuff. That's all required in basic subpart C of the 1926 standards. So take a look at that. Make sure you know where you're at. Make sure you plan for the rescue. Suspended workers, again, they run that risk of suspension trauma. So again, I cut off the blood flow from my legs that goes back up through my body. That's basically about a third of my blood flow. So if I've got it choked off, what's my body doing? My muscles constantly put off toxins, right? Because they're working, they're using up what they have, and they're putting away toxins, which go up into your kind of filtering organs to get rid of that, clean your blood and turn it back through, right? That's kind of the system. If I choke that system off and allow those toxins to build, and then 15 minutes later, 20 minutes later, I just release all those toxins, I've opened the floodgates, and I've just completely kind of overshot my entire system there. That can turn the body into a toxic shock type scenario, right? Orthostatic intolerance is what they talk about it. So you need to be able to rescue within minutes. Less than 30 minutes, somebody could die if they don't get rescued properly. So rescued suspended workers as quickly as possible. The best way is self-rescue, right? So if there's a way to get a ladder up to them and they're alive and breathing, we can put the ladder up there. They can turn around, grab the ladder, let themselves off their fall protection, get down safely, all is well, hopefully. If they have a head injury, what do you do then, right? So call 911, we follow their advice, but how do we get that platform up there? Can we use scaffold? Can we use a boom lift? Can we use a forklift? How are we going to get something up there in an emergency situation to be able to rescue that worker? So there's a ton of different equipment, and I have companies that will buy this equipment, and I go out to the job site and I never see the equipment, right? Well, we don't want it to get missing. Well, it's got to be out where the action is. You're not going to have time to run it out to the job site. So are you going to use ladder rescue, pole rescue, rope, scaffold, crane, aerial lift? What are you going to use to get them down? Employees need to be trained how to use it in kind of a check down mode of what they're going to go to next. Self-rescue stuff, they have, we'll go through this. This is a good little self-rescue device. It's basically a ladder in a bag. You go up above them, attach it to a secure point, drop the bag. This ladder comes down next to them. They can climb up or climb down, whichever way they need to go to get to safety. That's a great unit. They have this little, especially if you're working alone, a self-rescue system. They also have some retractables with a self-rescue system. But this system goes on the harness. You see the gentleman there, he pulls the cable. That's going to allow, there's a big reel of rope back in the pack here, and that's going to slowly descend that reel down, so that rope comes down. If you want to see this in action and you're on Facebook, you can go to my C-Inc Facebook page, and I have some video of World of Concrete like a year ago or 2 years ago, and the guy's up there hanging, he pops himself, he comes back down, goes right back up, does it again. So you can see how this works, but that system right there can really save you if you're working alone. You just pull the pin, you go down. This actually was adapted from like tower crane rescue, right? Because if you're up there, you start to have a heart attack. How are you getting down? How are they getting to you? You saw the big video where the guy was on the back counterweights on the tower crane, and there was a fire. Well, how does he get down? They made these packs to where it would be to the height of the crane, where you could just link up, put it on, throw yourself over, and slowly descend down. Now, I'd probably die of a heart attack as soon as I went over the edge because I don't like heights too much, but at least it gets them down in a pretty good pace. Rescue pole. Again, this is an extension pole, so I can reach out there and I can try to grab that D-ring and maybe pull you over to a window with that rope, or I can guide you over, guide you back to a ladder somehow. There's tons of these different pieces available. A few things they didn't show you there. I know they say if you're using a rope and you have a rope type device, if you're on a rope grab type system, I can bring this back up and make a loop and get my foot up in that loop and step up in that loop, and that gets the pressure off. I don't have that harness with me. There's another device that goes on the hips of the harness. Actually, he's got it. Oh, well, it looks exactly like where I've just put in red there on the harness. It's like a little zipper pouch. I unzip it and I drop down 2 straps, and I take those straps and hook them together at a height that when I stand on those straps, again, I can stand up in my harness and get that blood flow going through my legs. And that really just extends my window, right? So if I've got something where I can stand on it and I can allow that blood to flow, as long as I don't feel like I'm bleeding anywhere, I can just let that blood flow and I can sit back down. I can stand up and I can sit back down. And that's going to buy me time so I don't get that orthostatic intolerance, right? So those are some other ideas. You could go into self-rescue and rescue devices all over the place. So unless you guys have any questions, I'll kind of turn it back over here in a minute for our post test. But definitely get it, make it part of your written program, and train on it. Questions? Not everybody at once.
No, sir.
Okay, a couple other things. NAHB.org/safety. If you go to that website, or jssafety.org, they have some great safety resources for free that you can use. Some of them are like video toolbox talks that have been done in English and Spanish. I would highly suggest you take a look at some of those videos. If you don't have a program, some of the people who go to these classes, I talk to them, they're like, I don't even know where to start with a program. There's a sample program for a residential builder on there that you can use. And they have a lot of good resources for the whole COVID deal going on right now, both written programs, signage, etc., and a toolbox talk on COVID as well. So I would highly suggest going to those websites. They are the ones that helped put this grant together to get you this free training today. So I would check them out. Again, it's free. It's a great resource to use. Questions when it comes to fall protection, questions training, questions safety-wise? No? All right, Patrick, can you go ahead and issue the post test, please? Everybody's going to get the same link you saw before, same type link. This will be the post test. And if you guys can go ahead and do that, then we'll do a little wrap up after you're done with that. And then you'll have the course evaluation. Again, I'll need all 3 to say you successfully completed it. And once we're done with all 3 of those, I believe they have like a little certificate they'll end up emailing you after the course that you attended. So I appreciate everybody's patience and working with us through WebEx. And Patrick, go ahead and set up the post test, please.
All set. And Mr. Jim, I'm not sure if you even needed it or not, but I went ahead and emailed you the link to the post test. And I will be monitoring that as you guys move through it.
And Patrick, as those come in, if you want to go ahead and put up the survey so they can roll right into the survey, that would probably work perfectly.
Sure. I've already started to receive responses, so yes, I will do that right now. And again, just a heads up for everybody, this is the link for the survey. This does the actual evaluation of the course that you just took. So if you could also fill this out, that would be great. All right, Mr. Murphy, that was 100% completion on the post-test surveys. So we are in good shape.
Perfect. Well, again, thank you all for taking part in Safety Fest. I know this was a long one. Everything else is pretty much an hour. I think the insurance people on Thursday have some really good stuff, especially for fleet management, lowering your EMR and that sort of stuff. That's going to go an hour and a half, but everything else will be an hour, one of the sessions. If you haven't signed up for it, we do have availability in all the other classes. And again, Safety Fest is free. It's just CINC's way to give back to those people who have helped us out across the years, and hopefully some other people to just get them some good training for free. And hopefully you've enjoyed this, and any feedback would be great. So if you'd like to stick on and chat, I'll stick on for a few minutes. Otherwise, we are done. And I'm going to turn off the recording, and we can just open it up. So the recording